Good afternoon. I think we'll get started. And so people at the booths, please join us towards the front and please take a seat and we'll get started in 30 seconds. Yeah, we have seats on both sides and we'll give the innovators a little bit of time to get to the front. And if you're an innovator pitching later today, you'll see a seat with your name on it. We reserved it so that it'd be easier for you to get mic'd and to come on a little bit later. So please look for your name. They'll give. Yeah, so I invite people, please come to the front and take a seat and we'll get started. All right. Well, good afternoon. And I wonder what are the common threads and core beliefs that bring us all here together today. When I look around the room, I see DOE leadership, I see DOE program staff, I see lab leadership and scientists and engineers from our national labs. I see innovators, I see entrepreneurs, I see bankers, I see attorneys, I see students, and I see investors. What brings us all here? And if I may, I think I'm guessing that we all believe that science is the foundation on which innovation will deliver us a more sustainable, prosperous, and equitable world. I would guess that we also believe that the national labs have a significant role to play in that space, that we can be helpful. I also suspect that we believe that scientists and engineers can be amazing entrepreneurs. So I think those are the core beliefs that bring us here. And if you don't believe any of that, the exit is on your right in the back. But it's good to get the safety announcement out of the way as well. But I think those are the things that bring us here today. My name is Dick Coe. I'm the Director of Chain Reaction Innovations, the LEEP node at Argonne National Laboratory. You'll see the acronym LEEP, L-E-E-P, throughout the day. It stands for the Lab Embedded Entrepreneurship Program. It's a program that a U.S. Department of Energy program that originated from the Advanced Manufacturing Office. We're approaching our 10th year in operation as a program. But what we do is we bring in annual cohorts in clean energy, climate technologies, and critical industries of the future. We provide those innovators a 2-year fellowship to really focus on their business and technology development. They're embedded at the laboratories. They're paired with the laboratory scientists to de-risk that work. And the third thing that we do is we provide that initial critical funding for them to carry out that work at the national labs. And throughout, later I'll invite other speakers to come up to speak about the program, but at a high level, that's what LEEP does. So I want to make sure we all see that. So today is really an important day for many of our innovators. So we have 4 LEEP nodes at Chain Reaction Innovations at Argonne National Laboratory, Innovation Crossroads at Oak Ridge National Laboratory, Cyclotron Road at Berkeley Lab, and our newest member, Westgate, at the National Renewable Energy Lab. NREL, since they're just their first year, they're bringing in their first year cohorts, but the other 3 nodes are bringing in their graduating innovators. So these innovators have been in the program for nearly 2 years and have really de-risked their technologies, honed their skills. So today, later on, you'll hear more from them as well. So first, I would like to then introduce Argonne National Laboratory Director Paul Kearns to come up to please share some remarks. Thank you.
Thank you very much, Dick. Let me add my welcome to really the Department of Energy's Lab Embedded Entrepreneurship Program Demo Day. It is really wonderful to be able to host you today here in Chicago. I know we had intended to do this last summer and we're not able to due to the pandemic. And so it's really great to be in person. Last summer's event was certainly successful as we did it in a hybrid mode, but really appreciate the presence and the opportunity to celebrate here together in person today. And also want to say virtually as well, we do have our 3 national laboratory partners, Lawrence Berkeley, Oak Ridge, and NREL joining in today's conversation. And really, it's a pleasure to have everybody involved in today's discussion. Let me start by saying congratulations to our innovators from across our 4 LEEP nodes. You are doing incredibly important work from across all 4 LEEP nodes, making an impact with your technologies. Really fantastic in terms of what you're doing. I will say LEEP exemplifies how the national laboratories can partner with innovators and companies to translate early stage technologies into real world solutions. We have great examples of that in the room, and we'll hear from several folks this afternoon regarding just that. On behalf of Argonne, it is an honor to be a part of the LEEP program and to have the opportunity to support the best and brightest science and hard tech innovators that the U.S. has to offer. As I mentioned, there are 4 nodes across the U.S. Department of Energy National Laboratory Complex. They foster up and coming entrepreneurs who are moving exciting innovations from the laboratory to the market. Argonne's Chain Reaction Innovations, or CRI, is one great example. It supports the development of a wide range of technologies and companies for a clean energy economy. It is forging industries of the future that will boost our nation's economic competitiveness. In fact, CRI innovators are developing next generation batteries. They're enabling grid independent energy systems, and they're inventing numerous technologies in between. Our program has become a magnet, really drawing some of the most promising innovators to the Chicagoland area. Many are putting down roots and building facilities, hiring staff here in the region. Other nodes are also seeing inspiring results. At Oak Ridge Innovation Crossroads, they are making more sustainable materials. At NREL's Westgate, they are making homes healthier and emissions free. And at Lawrence Berkeley Cyclotron Road, they're commercializing recyclable polymers for a more circular economy. And that's just a small sample, really, of the effort that's underway and the great work that the LEEP entrepreneurs are doing. Our national laboratories participation in LEEP has not only benefited the startups that we're working with, but also the national laboratories. We gain a great deal of perspective and really value the conversations we have through the questions they ask and the technologies and the science they bring to each of the laboratories. It really is multiplying collaborations between entrepreneurs and scientists in a very healthy way, really an organic way, which we're quite pleased with. And it's laying the foundations for subsequent and very impactful advancements across many technologies. In the 7 years since the program launched, CRI has supported 35 innovators and who have raised $427 million in funding. The companies they've established has created 641 jobs so far. Really a fantastic set of accomplishments, remarkable impact. And we look forward to seeing what comes next from these exceptionally talented individuals like those we'll get an opportunity to interact with today. I also want to note that CRI promotes diverse teams that empower our mission. A variety of experiences fuel our dynamic collaboration and the transformative science that we have underway. That's why we're intentional about inclusion. When we recruit our innovators from diverse universities and colleges and the outreach activities we undertake with them to unconscious bias training for our pitch competition judges, we are taking steps to ensure that all are welcome. The data tells us that our approach is working. 48% of the startup founders who have gone through CRI are from underrepresented groups, and 30% are women. Our seed internship program is also contributing to this improvement. It is giving Chicago students who attend minority serving institutions the opportunity to work side by side with CRI innovators, gaining really invaluable experience. It is positioning them to pursue STEM careers and to make an impact like their mentors are With different ideas and backgrounds, we're really accelerating the science and the technology that drives U.S. prosperity and security. Our future success truly depends upon this effort, and we're pleased that we are moving in the right direction. Before I can conclude, please let me extend my appreciation to the Department of Energy's Advanced Materials and Manufacturing Technologies Office for their vision, leadership, and support of the LEEP program. We're pleased to have Paul Sayers representing the office here today, along with Joe Cresco. I think Joe is here as well. There he is. Hi, Joe, from Industrial Efficiency and the Decarbonization Office. We're quite privileged to have and want to extend a big thanks as well to the Department of Energy's Undersecretary for Science and Innovation, Dr. Geri Richmond, for participating in today's events. Really a value add for all of us, and being our keynote speaker. Thank you very much, Geri. And finally, I want to acknowledge John Labarge. I spoke with John earlier. Where's John? Hi, here he is back here. John is Director of the Office of Laboratory Policy with the Department of Energy's Office of Science, one of our key partners at Argonne and also Berkeley and Oak Ridge. So really pleased to have John here. LEEP simply would not be possible without the support of these leaders from the Department of Energy. And so I want to acknowledge really their vision, their leadership, and the very effective partnerships we have with each of them. Finally, I'm really grateful to today's event MC, Dick Coe, the other speakers that are participate, our event organizers. Things look fantastic. We're really privileged to have a great crew supporting today's effort. Our corporate sponsors and the sister labs that are also participating in helping the event be successful. Their hard work and really the dedication are commendable. So congratulations again to the innovators from all of our LEEP nodes. Please enjoy today's events, which will showcase new technologies and systems that will go a long way towards shaping a better tomorrow. So thank you again for helping us open new frontiers for America's energy future. Back to Dick.
Thank you, Paul. And next, I do want to acknowledge our sponsors for making today's event possible. So we'll go to the next slide, please. And with that, I would like to invite our first sponsor, Mary Brown, who is the Senior Sustainability Specialist at Wells Fargo, to please share some remarks.
Thank you for the warm introduction, Dick, and good afternoon. I'm happy to be here with all of you and eager to hear from our other speakers and presenting innovators later on. At Wells Fargo, sustainability means supporting our customers and our communities as we all transition to a more resilient, equitable, and sustainable future. We serve households, small businesses, wink, municipalities, mid-corps, and large corporate clients. And across the board, we're seeing the need for innovative, clean tech solutions that help our clients meet their sustainability goals and ours. And to be clear, this isn't a new area of focus for Wells Fargo. Since 2014, we've funded and partnered with NREL on the Wells Fargo Innovation Incubator. See in my NREL team. So that might be more commonly known to a lot of you as IN2. It seeks to accelerate the rate of commercial adoption for innovative clean tech solutions in 3 areas: commercial real estate, affordable housing, and sustainable agriculture. We're very proud of IN2 and the impacts that our founders are driving in the real world. But we also know that innovation doesn't happen in a vacuum. And the saying isn't exactly, it takes a clean tech ecosystem to raise a startup. I think it takes a village, but jokes aside, Wells Fargo is so proud to support this event, which brings together the critical ecosystem that we all benefit from, of national labs, investors, banking partners, industry partners, incubators, accelerators, and of course, innovators. So thank you all for being here and for being an important part of this ecosystem.
Thank you, Marion. Next, I want to invite up Dr. Jill Foose, the Managing Director of Activate Berkeley, to share some remarks. Thank you.
Thanks, Dick. I should say that Activate partners with Berkeley Lab. We're a nonprofit that partners with Berkeley Lab to run the Cyclotron Road program. So I think when Activate and Berkeley Lab identified a gap in the science to market ecosystem and launched this experiment at Cyclotron Road in 2015, I don't think anyone expected this new model of innovation, the Entrepreneurial Fellowship, that it would grow to be as successful and impactful as it's grown in the last 8 short years. Since 2015, with funding from DOE's advanced manufacturing offices, Activate and Cyclotron Road have welcomed 9 cohorts. That includes the one that started just last week, which amounts to nearly 100 fellows across 72 boundary pushing companies that have gone on to raise nearly $1.1 billion in follow-on funding. Yeah, thanks. Whew. So Activate is proud to be a LEEP Demo Day sponsor and part of the effort to empower science innovators around the country. In partnership with the huge technical capabilities of Berkeley Lab, we bring the entrepreneurial education, the high-touch mentoring, and the community and network building that is so crucial to a new entrepreneur's startup journey. And as a nonprofit, we're able to leverage additional funding from state and federal sources, philanthropy, and corporates to bring on even more innovators into the fellowship. But we're really only scratching the surface of the need for this support. In 8 years, we've received 2,600 applications from nearly 50 states and hundreds of research universities and institutions. There is so much talent out there who have innovative technologies, but no clear path to market. We are here to celebrate some of that incredible talent here today, and I would encourage all of us, maybe even challenge us, to think about how we can support even more innovators and catalyze the innovation ecosystems across this country. So thank you to CRI for hosting this exciting event, and to our partners at Berkeley Lab and DOE for taking that first step with us 8 years ago. Thank you.
Thank you, Jill. So next, I would like to invite up Dr. Paul Sayers, the Technology Manager from the Advanced Materials and Manufacturing Technologies Office, to introduce our keynote speaker. Paul.
Thanks everyone for being here, for coming today. I'm also very excited to be here for a program, just a really wonderful program that we have been proud to support over the years. I'm also excited to introduce our keynote speaker. And before she gives the keynote talk, we have a really, really great panel discussion that she will lead. It is my pleasure to introduce Dr. Geri Richmond, the Undersecretary for Science and Innovation, which oversees the Office of Science, which is the nation's largest federal sponsor of basic research in the physical sciences, as well as the Department's Applied R&D and the National Lab ecosystem. Pretty broad thing. And I can't think of anyone better to do that because she really embodies science and innovation. She is the presidential chair in science and the professor of chemistry at the University of Oregon. She holds the National Medal of Science, as well as many other nationally recognized medals. She served 2 terms as a presidential appointee to the National Science Board. She was the founding director of the grassroots organization Coach that has helped over 25,000 women scientists and engineers in career advancement in the US and around the world. It has been my pleasure to work with her over the past few months, and she has an endless amount of energy and excitement that you cannot help but have rub off on you, and you leave every interaction inspired. So it's my pleasure. And if we can have all the panelists come up here as well.
Man, he set the bar high. That's great. I'm delighted to be joined here by the panelists and so delighted to be here. This is such an exciting day. And for all of us that love seeing science advance to different stages and onto entrepreneurship and success of this nation and everything else. So I thought we'd start out today with these three panelists. I'm going to let them introduce themselves, but they are our success stories here. You notice, of course, there's kind of a gender imbalance on the stage right now. That's good. That's good. So all you guys out there, just know that we see you too. Okay, so I'm going to get started by letting them introduce themselves each, so you see what an amazing group we have here. And then I'm just going to ask a few questions. Oh, give your mic. Yeah, your mic.
I think so.
Okay. Yeah.
Can you hear me? Yeah? Oh, okay.
Good.
All right. Yeah, so my name is Julie Bloomreiter. I'm the co-founder and CTO at Clear Flame Engine Technologies. We were part of chain reaction cohort 1. So we were the guinea pigs going through figuring out this whole lab embedded entrepreneurship thing. Clear Flame converts diesel powered heavy equipment to run on cleaner fuels, and it offers lower costs per mile than diesel and lower carbon per mile than an EV.
Hi, my name is Kezi Chen. I co-founded Flow Materials, and now I'm the CEO of Flow Materials. And I'm a Cyclotron Road Fellow for 2021, so I just graduated from the program this month. And yeah, we work on infinitely recyclable plastics, and we're commercializing a new material called PDKs, developed at Berkeley Lab, and we're commercializing this new material and bringing it to market.
And my name's Anna Douglas. I'm the co-founder and CEO of Sky Nanotechnologies. We're a cohort 1 company from Innovation Crossroads at Oak Ridge National Laboratory. And Sky Nano is really a carbon management technology company. So we do carbon dioxide capture, conversion, and storage kind of all wrapped up into one. And we're actually storing CO2 in the form of solid carbon nanomaterials, which are then reused in consumer applications. So we say, instead of sequestering carbon, why not use it in the materials and devices consumers already use?
That's great. This is like a great team, or what? Are you going to hear more? Okay. All right. Okay, Julie. Here we go. In the 6 years since you've left Chain Reaction Innovations, as you've grown in your career and scaled up your business, in what ways has LEEP helped you?
So I can say very unequivocally that ClearFlame would not exist if it were not for the chain reaction program. We talk here a lot about the valley of death between sort of these hard tech concepts or even proof of concept, and then having enough of a compelling, business model and enough data or a prototype to then go and raise venture capital funding. So for us, CRI absolutely bridged that gap. We were at Argonne for just under 3 years total. We had done some, follow-on work with some of the scientists, and the credibility of having Argonne scientists say, yeah, you know what, I didn't believe it either till I saw it work in the lab. When people would ask them about it, those 2 years to have, developing our, building a financial pro forma for the first time when, we were scientists and didn't even know what that was coming into the program, as well as the connections in the ecosystem. We founded our company in Silicon Valley and moved it to this area for CRI. And we talk all the time about how that was one of the best decisions we ever made for just so many reasons beyond what we could have understood at the time.
Great, thank you. Okay, Jesse, you're up next. Now, here's my question for you. So for those in the audience that may be unfamiliar, your company is Flow Materials. It's commercializing a new type of plastic called polydiketoenamine, and that increases the recyclability of historically hard to recycle products. And may I say that I have bragged about your work to the secretary at the Department of Energy, just to show that I know exactly what you're doing, being a chemist, and I'm so excited. So what do you think was the single most important factor in getting your company going?
Yeah, I think success in entrepreneurship is subjective. It could be the amount of funding you raise. It could be the number of people you employ. It could be how much IP you get out into the pipeline. And for us, I think it's the single most important factor, besides the funding, the 2-year funding to take a risk and do this right out of PhD, as well as the lab space where we get to use equipment, NMR, we get DSC, we get all these equipment for free, which would cost an arm and a leg for an early stage hard tech startup. We get that for free, and it's really accelerated us towards, making progress and testing something from a few grams to a few kilos and making a product. So I think just everything, I can't choose one thing that contributed to the success of the company. And I think we're still growing, we're still pushing forward. And I also would say that in addition to the funding and the lab space, there has been so much mentorship in LEEP. I've learned how to be a leader in this process. I've learned how to be an entrepreneur, a first-time entrepreneur. Yeah, that's been extremely valuable.
That's great. And may I add to that, when you can use the equipment, you don't get thrown into the laboratory with an instruction book. There's also people around you.
Yeah, they help us. Yeah, it's amazing.
Oh, that's great. Anna, okay, you are another LEEP alumni, and you were a member of the Innovation Crossroads in 2017 also, is that right?
That's right.
Okay.
Yep.
So looking back over all of this, what would be your advice to early stage startups as they graduate from LEEP?
So I think generally in entrepreneurship, in particular in the clean tech space, there's a few very specific storylines that are told as success. And Kezzy sort of alluded to this a little bit. There's a lot of different ways to define success, but in particular, there's kind of one general storyline and path to building a company that everyone here has heard about. And that's, you get a couple grants and then you get, a big VC round, and then you build out this like huge infrastructure and, and then you're off to the races. And I guess my advice would be there's a lot of ways to build a company, and they don't all look like that. Some of them are slower, and some of them include a lot of different types of pots of money from a lot of different sources. And some of them include sales and trying to actually get product into the marketplace really early, way before you're actually building out, your huge manufacturing facility. And for Sky Nano, that path has looked a little bit more like that. It's looked a little bit different, maybe a little unconventional. But we've raised exclusively non-dilutive funding so far. We've actually started selling some of our CO2 derived carbon products into really early stage marketplaces. These are R&D labs at companies trying to develop product lines, but we haven't followed the model that, you would typically see on, the cover of Forbes and, in these big magazines. And so I guess my advice is there's a lot of ways to build a company that would quantitatively be qualified as successful. And LEEP really gives us the ability to explore a lot of different business models. And I think, there's nothing better than taking advantage of that.
That's great. Okay, Julie, it's your turn to give advice. What advice do you give to a newbie to the LEEP program?
To someone coming in or graduating?
You choose.
Okay, I'll choose to someone early or mid program. Just take advantage of everything, and like the nodes are plugged into the local, additional ecosystem. So the connection between Argonne and UChicago and the business school was one where we were able to get some really great, summer interns or be part of pitch competitions or, be part of MHub as well as CRI. There was a lot more in the surrounding ecosystem, and that has ended up being the part that has really served us, after as well. So, some of the mentorship came through that direction, but also the introduction to different investors and everything that you need, all of the, auxiliary parts that it takes to build a successful company are there. And so it's not only about being in the lab, even though having access to millions of dollars of equipment I never could have afforded was amazing. It's still also that peripheral ecosystem that'll make it successful.
Well, that's great. Lizzie, what advice would you give to someone who's thinking about applying to LEEP?
I would say I heard this from someone else, and it's obviously true. Startups are inherently risky. Like you just can't take risks out of startups. But what LEEP offers and what this program offers is a safety net. And it's a safety net that I took to embark on this entrepreneurial journey. And I would just say, like, jump feet in and just go for it. And we frankly need more science entrepreneurs out there. So just try, if you can get into this program, definitely do it. It's one of the best decisions I've ever made.
Wow. Okay. Any of you, last advice before we go on to the next question? Anything you've forgotten or you want to agree with someone else? Or you want to agree with all?
I mean, I would absolutely ditto. If you can get your foot in the door in a program, just take the jump. I mean, what's stopping you? It really is an amazing safety net to try a lot of different things. There's really nothing like it. There's no other like federal funding program that I'm aware of, at least, where, you're funded to basically try an idea for a couple years, and there's no, hard cutoffs, and, there's no very strong deliverables. I mean, you have to, do the work, but you really get to explore and pivot. There's nothing else like this. It's a really amazing program.
That's great. Julie, anything you want to add?
No, I appreciate how much it's structured to incentivize innovation. Like having the, you didn't pass gate 1.5 because you didn't deliver, this thing you thought of a year ago. It is, you get to continually redefine success as you go. And I don't think any company that came in did what they thought they would at the start, and they were probably far more successful for having had that adaptation and pivots, those opportunities along the way.
That's great. Well, since I've got these three women up here, I'm going to ask a gender-related question. And that is that if you could identify, I'll give you a second to think about this, but only a second. Think about, what do you think is a major challenge for women in wanting to be entrepreneurs, and what's an opportunity for women wanting to be entrepreneurs? Okay, so you can think, and who's ever ready, raise your hand. Because you look like you're ready.
I'll start with the problem, and then maybe we can all jump in with some solutions.
Yeah, then let's have it be a conversation.
I was recently in Abu Dhabi for an all-women's Forbes conference, and it was there that I learned that 2% of venture dollar funding goes towards all female-led teams. 2%, that's a tiny number. And it's not even that much more for mixed male and female teams. So that's a huge gap that we need to still work towards. Just because there are three of us sitting up here, it's not representative of entrepreneurship, it's not representative of science, and it's not representative of science entrepreneurship. So we need more help, I think. And for me, I think one of the most important things is, if you are a female leader, then you can recruit more female scientists, and it's a dominoes effect. So yeah, we need more female leaders in power, I guess, and making decisions. We make good decisions.
Yeah, I'll ditto that. We actually had an intern last summer, intern with us at Skynano. She's a University of Tennessee chemical engineering student. I mean, one of the brightest students I've ever worked with, in my life. And she worked with us all summer, and then she kept working with us a little bit even after she went back to school in the fall. And so eventually we said, look, you're awesome. Will you please join us full time when you graduate? And she took, the normal like weeks to think about it. And she came back to me and she said, this is a no-brainer. And it's in large part because this is a majority female team, and I can't find that anywhere else that I'm looking. And it's not that, it's a nicer place or a better place. It's just, I have people that look like me, that talk like me, that think like me, that, we can all come together and have different opinions. And I know my opinion is not going to be discounted because I'm a woman. So I think particularly for really early career scientists and engineers to be able to see, I would still call myself early career, but still, like fairly early middle career scientists and engineers in leadership positions, leading teams with a lot of women on them. I think it's very valuable, very impactful.
That's great. That's great. Julie.
Yeah, early on, BJ, my co-founder, and I had a very, very honest venture capitalist look at us and say, we invest in people that we trust, and we trust people that look like us, and neither of you two look like me. And he was saying that to let us know these are the waters you're swimming in. And so one thing that I want to kind of, I guess, propose to any investors in the room is, we all want to be very data driven, right? So statistically, female-led companies outperform male-only led companies. And so I think in addition to just a degree of awareness of the types of bias that we as humans will just naturally bring to the table, there's also an opportunity to look at data and consider, if you're making a bet on a female founder, it's likely to be one of the good bets that you make. And we all like good odds. So that would be some encouragement that I would offer. The data speaks for itself, even if it's not what's going to be our natural inclination. But by overcoming that, you can have an unfair advantage by investing in people that are most likely to succeed.
Wow, that's great. Okay, I'm going to cut into my keynote, but I'm going to ask, and that's fine. I'm going to ask one or two questions from the audience of this group. I'll put you all on the spot. Anybody raise a hand? Or even congratulate, whatever you want to do. It's like teaching freshman chemistry. Nobody raises their hand. Come on. You're not a quiet bunch. Yeah.
First into the LEEP program. And then as you graduated, what did that feel like? Like, what was the next scary step upon like exiting the embrace of the lab system?
Yeah, so what was the scariest part about the big leap? Great question. Who wants to take it first?
I'll take it first. So we started in 2017. So technically our CRIDA ended in 2019. We still had CRIDA dollars left to spend. We got an extension. And so we ended, right as the pandemic was starting. So that was a very strange time for everybody. But particularly for us, a few things were really important. One, we spent the 2 years in the program developing very great relationships with the ecosystem that we were in. So, in East Tennessee, this is not a natural place for hardware technology startup companies to congregate, but Innovation Crossroads really was an amazing catalyst for all these different resources to come up around and support this. And it really now is a thriving hard tech ecosystem. There's Innovation Crossroads, there's Spark Business Accelerator, which is more of like a lab space that you can go rent model. And we even have a Techstars program there now. So, it really is a big ecosystem. So I think leaping out of LEEP, find an, I don't want to say another safety net, but find your people, find your village, find your ecosystem, find the right partners there. That was really important for us. And then quite frankly, the scariest thing was space, physical space that meets our needs. This is by far the hardest challenge I have run into. Building a team is hard, finding good talent, that's hard. Money, you can wire from anywhere, but finding physical space that meets our needs, very challenging. Julie and I were talking about like very, very high power requirements, and we're asking for 2.5 megawatts at our new facility. That's a lot of power. We need to be able to cut a hole in the roof to do proper ventilation. We need, lots of like crazy plumbing requirements to do waste management. And these are not things you find readily available. So I think, if I have an ask of anyone in the room who is in a position to help these types of things, think about, how innovators are exiting the programs and just physically meeting their needs. Where are they gonna set up shop? We're leaving a lab infrastructure that has professional waste management capabilities and a generator on site and things like that. And so I think just meeting physical needs where they are is kind of the largest challenge that we ran into.
Great. And I know, Kezzy, this morning in conversations, you were talking sort of along that lines too, but is that a scary one for you now as you go forward?
Yeah, we have our CRADA ending in October and we need a lab space and it takes 6 months or more to find lab space. And you're constantly fighting between having enough funding, making sure your IP is up to date, making sure you're actually making technical progress to product development, and then making sure your experiments don't stop just because you're looking to move from one space to another. So there are tons of requirements, and at Cyclotron Road, we're talking with fellows who are all graduating to see if there are ways to sublease and share space, because even after graduating, we still, are looking for funding. We're still pretty early stage, but we have de-risked so much as compared to if we didn't do this program.
Yeah, great. Julie, last word. Words that.
Last words.
Scary.
Yeah, I mean, what was scary, signing a 5-year lease on a facility that we still needed to build out. And now it's scary because we're 3 years in and our permitting is still not all the way done. And like, we're going to get there because like, nothing is going to stop us, but like, man, is it painful. It's really hard.
Well, I don't know if all this pain is something we want to expose our new our new folks to, but they're surviving and they're going after
Yeah.
it. So big kudos to the three of you. Thank you so much for being willing to be part of it. Great. Anyone that has done science or scientific research knows that there are a lot of challenges out there, and you just keep going. And there are no failures, because if you learn from it, it's never a failure. So kudos to everyone involved in the program. Well, let me just say a few words before we move on. First of all, I want to say how delighted I am to be part of this. Because the Department of Energy just feels so strongly about the need for entrepreneurs, particularly in the energy space. And I just love the excitement and the passion of those that are really launching into new ventures in their careers, starting their own companies, and also all of you that are supporting them, whether it be a spouse or whether it be someone that is helping finance or helping them find space or just giving them encouragement. It takes a village of support to keep this all going. And at the Department of Energy, we like to think we're part of that big village. So I really want to thank our outstanding team at the National Labs for participating in today's demo day. I'd also like to acknowledge the scientists and entrepreneurs in this room, innovators like you that breathe life in our investments in the Department of Energy. You are moving us all closer to a clean energy future that will benefit all Americans and the globe. And today we need you more than ever before. We cannot tackle the climate crisis without bold innovators who share our belief that a single idea can change the world, a world that is now burning up. But as we all know, having a great idea you believe in is only one piece of the puzzle. As pointed out by our panel, without the funding, the research facilities, the professional mentorship, the great ideas can only go so far. Successfully maturing a science-based clean energy tech innovation into commercialized technology is, as you've heard, and you will hear, no easy feat. It requires an ecosystem, innovative ecosystem to be behind it. And again, that's why we're here today, to provide that type of an ecosystem to push us all forward. But I also want to say that that's why our Advanced Materials and Manufacturing Technology Office, or AMMTO, created this lab embedded entrepreneurship program back in 2015. And the focus of LEEP, as it always has been, is to support entrepreneurs at their early career stages, helping them to traverse the infamous valley of death and transition promising ideas at the lab into breakthrough technologies and American factory floors. And as someone who's spent their career mostly in academia, I wish we did more in academia all the way through undergraduate degrees and graduate degrees to get our young people to understand the challenges and the excitement of being able to go to into entrepreneurship. It's very, very important, I think, and we could do better. But we do this here today by connecting entrepreneurs with the entire network of experts who believe in the ideas that we said here, starting with the national labs. I couldn't be more proud to be overseeing the 14 national labs that I oversee and keeping track of the other 3 that sit in the NNSA category. It's pride that I talk about every chance that I can possibly get, including talking to the White House OSTP this morning about the amazing things that go on in our laboratories. These LEEP entrepreneurs are given a 2-year fellowship at Argonne, Lawrence Berkeley, Oak Ridge, and National Renewable Energy Laboratory, as you've heard. And this is really an amazing thing for the labs to take on because it's not necessarily written down as their day job. This is really people giving extra time, extra efforts, because they believe in the entrepreneurs that are going to come up through the system. And so many times I've talked to folks from the lab that are not in the entrepreneur program, that they have helped with the entrepreneur program, or they've just watched it and they just beam with pride at these different laboratories at what's going on, because they know that these are our future leaders, and they need to get the technical resources, mentorship, and access to powerful networks that will be the launchpad to successful clean tech startups. We need to help them build their networks. We need to help them build their networks, because especially nowadays where our connectivity with each other, our meetings aren't nearly as attended as they used to be, our networking is a little bit more challenging. So help us in any way you can to help them get networked with each other. And that's what DOE is working so hard to help foster, to be these energy champions of tomorrow. So bragging a little bit about the track record to add what's already been the bragging from a couple of the labs. The proof is indeed in the pudding. Over the last 8 years, LEEP has served an incubator for more than 150 startup founders who've garnered $1.5 billion in follow-up funding. Isn't that great? Really great. And they raised it $1 at a time. It's not as if it comes in big wads. It's little wads and here and there wherever you can grab it. And startup founders, 150. That's amazing, truly amazing. So, but let me also say that we also recognize that too many of our historically, too many of our groups have been shut out from STEM and certainly in tech-related business opportunities. And that's why diversity, equity, and inclusion are major priorities for the Department of Energy. I've been around the Department of Energy for probably 25 or 30 years, hanging on, doing advisory board activities, as well as doing reviews and getting to know DOE very well. I have to say, in all those years, I have never seen the commitment to diversity, equity, inclusion like I see now at the Department of Energy, integrated in all the programs. We take this very seriously, all the way from the secretary down and from the White House. We know what it means to do science when you have a very diverse group of people with ideas, diversity in all dimensions. We can understand diversity with regards to scientific areas, but we also mean diversities of different ideas, people from different social and economic backgrounds. I myself grew up on a farm in Kansas. Whoever would have guessed that I would be where I am today? And yet it was people that accepted me into their laboratories that allowed me to prosper and grow. That's America. And that's what we want to make sure that our STEM workforce looks like America. And that's what we are very much committed to with this LEEP program. We're proud to say that 40% of the LEEP fellows from historically underrepresented groups and 26% are women founders. And I know that we didn't quite represent 26% here, but we had 100 up here, but you can do the numbers. It's really great. This program is a testament to the fact that when private sector and government work hand in hand to scale new technologies, we can develop the solutions that will push the clean energy transition past its tipping point, cleaning up industry, creating good jobs, and making sure that all Americans share the benefits. It's this can-do attitude that you heard here, that you're going to hear this afternoon, that really is making this all work. And we're so happy to be a part of it. So a big part of what we're doing at the Department of Energy, which is new just over the past couple of years, is to create these Earth Shots. And these Earth Shots, I just want to say, is an initiative that, again, we're very concerned about making sure it's very inclusive. But what we've done in these earth shots is we've identified, now we're up to 8 areas, just announced, I think 7th, 8 areas where there are areas of technology that we have to get over the barriers to actually get to the point that we have carbon dioxide removal, that we have better batteries, that we have geothermal heat that we can use as much as possible. There was all these, there's in all of these earthshot offshore wind, all these areas, there are technical issues that have to be solved. There are companies that need to be started up in this area so that we can reach the kind of goals that we have set in 10 years to have them be, these technologies be totally commercializable. And this group is going to be part of that, helping us to move forward. And those of you that are going to talk to us this afternoon, you're part of that too, because the 7 earth shots that we've just announced, including products and fuels, clean products and fuels, are the ones that are going to make a difference. So enough from me. I invite you to watch and listen as they now pitch to us their ideas, and then stay to network and listen, learn more from them, and become inspired by their remarkable ideas that will be coming from this room. And after the pitch presentations, I hope to see many of you at the networking reception. Thank you. Thank you so much for being here.
As we reset the stage for our innovators to pitch, I want to thank Dr. Richmond for her keynote. And I certainly, like Paul said, I feel inspired every time I hear you speak. And let's all do our part, right, to help our innovators scale and to network and to connect them into the fabric that we all have in our regions. So one thing before I invite my colleague Dina up, I want to take some time to really thank the people who put this event together. Many of the leaders have come to me and say, Dick, this really is a heavy lift, and it truly is. So I want to call out just the CRI team, especially for months and months of putting this all together. So a round of applause for the CRI team. I also want to thank, and that's just the tip of the iceberg. We also have the Argonne event staff, creative services, and audio and visual, and also the LEEP nodes. We met bi-weekly for a few months now. And again, this is really a team effort. So I want to thank the LEEP nodes and the LEEP node staff for being a part of this team. And last, and certainly most importantly, I want to thank Paul Sires and Joe Cresco and the DOE team for just having the vision to start this program, continue to nurture it, and certainly coming together for this program today was also a lot of work on their end. So thank you to DOE. Okay. So quite literally, the stage has cleared. So I want to invite up my colleague, Dina Wright, who is the Fellowship and Program Manager at CRI.
Thanks, Dick, and thanks everyone for joining us today. I'm so excited to be here to introduce these guys to you. They're fantastic. You're going to love it, and I'm just really ready for this part of the program to start up. It's my favorite. They're all here to tell you about the really great things that they're doing, and it's just amazing. I'm so honored to be part of this and to be part of their journey as they're building up these technologies and learning how to become entrepreneurs. It's just fascinating to watch. So thanks, Dick, for the great explanation about CRI. I don't really have to jump into that. You guys all understand what the program does. So I'm just going to go ahead and introduce our first innovator who's going to speak today. I know he's excited to be here. He's ready to go. So without further ado, I'll introduce Dr. Hongjun Zheng. He'll tell you about his company, Adaxius.
I think everyone heard about a 10-pound hydrogen fuel can drive a car over 300 miles. But the hydrogen tank itself is about 150 pounds. We also know the windmill can provide clean energy, but it's difficult to install and maintain their heavy blades. In the aerospace, the situation is even more exaggerating. sending each pounds of goods to outer space will burn $10,000 of payload. All these problems comes from different area, but they share the same bottleneck. The materials around us are not tough enough, light enough, and hence energy efficient enough. The recent progress of the carbon composites, especially those made of carbon nanotubes, carbon fibers, provide great opportunities to enhance the mechanical performance of the structural materials. But serious issues arise when they're used in actual work. The most complicated problems are caused by the incompatibility between the carbon reinforcement in microscale and the matrix resin in macro world. Such incompatibility generates a lot of tiny gaps, voids, and defects. In situations involving high speed, high temperature, high pressure, these defects could lead to a catastrophic failure of an airplane or hydrogen tank. And at Access, we're addressing these kinds of problems. The solution comes from a patent pending technology we called vapor phase surface engineering. The technology can functionalize the carbon surface with extremely high uniformity in nanoscale, so that the liquid resin can penetrate into each corner of the nanostructure of the micro reinforcement and leaving no space to the defects. We have demonstrated the composites with this technology improved their ultimate strength and the technology and the toughness by 40% and over 400% respectively, without adding significant weight and cost compared with the commercialized equivalent. Such a leap of the composite manufacturing fully unlock the potential of carbon composites, which could lead to light payloads of aerospace, efficient vehicles, durable wind turbines, and high performance sporting goods. Oh, sorry, I think it's faster. And these applications holds a huge market projected to $170 billion. At this moment, our initial product will serve aerospace with addressable market size of 360 million. Here's a short but exciting story about Adaxius. It was born in 2021. In just 2 years, the technology has been developed from a chip scale to a yard cell, not yard cell, yard size, sorry. And we have alliance with lead composite manufacturer in aerospace, and we're luckily selected by this Chain Reaction Innovation Program, as well as the National Science Foundation SBIR program. A few leading technological and the business platforms are also support us for the development of process, product, and business. We got a perfect team combined with successful entrepreneurs and investors, experts of nanotechnology, surface engineering, and composite manufacturing. We're raising about $1.8 million to expand our team and customize a bigger size rules and upgrade our manufacturing base. Beyond this, we welcome all kinds of collaboration from you guys to enrich our talent, the investment, the partnerships, as well as the pilot opportunities. This is about the Dexius, a company devoting to stronger, lighter, and more cost-effective advanced composite materials. We hope one day Elon Musk could use our materials to replace their cumbersome stainless steel in their rocket. Thanks for your interest and questions.
That was really great, Hongjun. I think we should give him an extra round of applause for being the first one. Hongjun practiced a lot and he's doing so well. We had a coach come in and help him, and it's just been really great to watch his progress. I'd like to welcome our next innovator up, who I know is equally excited and ready to go. She's going to keep the same bar. Arsheen Alam, coming up from Go LEEP.
Can you hear me? Okay. We use batteries every day. And since batteries were first developed in the 1800s, we've been making incremental improvements to them, even to this day. And this is to address their current limitations of low power density, long charging times, and short lifespans. However, at the rate at which our renewable energy is being generated, our capacity to store and release that energy is significantly lagging. The graph on the right of this slide shows that the pace of our renewable energy generation is growing at 20 times the pace of our capacity to store that energy. For this reason, we are in need of a supplemental solution to batteries to address their shortcomings if we truly want to move the needle in the adoption and use of renewable energy. This is where supercapacitors come in. Supercapacitors have 100 times the power density of batteries, which means they have faster response power, which is critical when there's a peak load on a system or on the grid. This reduces peak shaving costs and improves grid resilience. The reason why we don't see supercapacitors being widely used today is because the materials needed to make supercapacitors are very expensive. These are materials like carbon nanotubes, graphene, and metal oxides. This limits the use of supercapacitors to only high-value products or areas. Go LEEP has developed a proprietary process to extract reduced graphene oxide from virtually any carbon source, including carbon waste streams. Our patented chemical process is up to 90% lower cost than traditional graphene production methods. It's highly scalable, and it emits up to 80% less greenhouse gases. Using this low-cost source of graphene, we have developed a supercapacitor prototype. And this prototype has already demonstrated to have 3 times the power density of leading supercapacitors on the market today. To give you a use case, the Tesla Model S uses a supercapacitor that has a power density of 10 kilowatts per kilogram. The Mercedes EQ uses a supercapacitor that has a power density of just 3 kilowatts per kilogram. Go LEEP's supercapacitor prototype has a power density of 15 kilowatts per kilogram. For those energy storage savvy people in the audience thinking, okay, well, what about your energy density? The Tesla Model S's supercapacitor has an energy density of 8 watt hours per kilogram, and the Mercedes EQ supercapacitor has an energy density of 10 watt hours per kilogram. Go LEEP's supercapacitor prototype has an energy density of 15 watt hours per kilogram. This means our supercapacitor solution delivers more power for a longer duration at a quicker charge than industry leaders, all at a lower cost. The supercapacitor market is estimated to be $24 billion, and we anticipate addressing $7 billion of this market in 3 key product areas: electric vehicles, uninterruptible power supply or UPS, and grid storage for frequency regulation and eliminating unstable power transmission. Supercapacitors are the tip of the iceberg for GoLEEP, however. Our low-cost graphene oxide offering is a platform technology that opens up market opportunities across industries ranging from water filtration to composites and construction materials. Our business model is to scale our graphene oxide production, and we are currently working with former NASA robotics engineers to automate our process. We're also in discussions with strategic partners to commercialize our highly versatile graphene oxide offerings. And our long-term strategy remains to continue to develop and grow our graphene-based product portfolio with products like the supercapacitor. Our team consists of material science, civil, environmental, chemical, and computer engineers. We have tremendous experience in both the business and legal realms, with several of our team members having successfully started and exited companies in the finance and energy sectors. We're currently collaborating with Dr. Yupeng Zhang, a senior material scientist at Argonne National Lab, to further our graphene oxide capabilities. And we're very fortunate to have the support of some amazing organizations like Duke and Rice University, the Clean Tech Open, Plug and Play, Forbes, and the Chain Reactions Innovation Program. Up until now, we've been self-funded and have won a number of prizes and grants, including $750,000 from the Department of Energy. We are now seeking a $3.5 million seed round to scale our graphene oxide production and optimize our supercapacitor product. This will lead us to our Series A round in 2026 of $37.5 million, which we will use to set up our scaled graphene and supercapacitor production plant. And we anticipate generating $24 million in supercapacitor and licensing revenue in year 2028. Thank you, and I welcome you to join us at our booth after this.
Thanks, Arsheen. That was great. I love the new slides. There's a few on there I haven't seen yet. Really well done. I'm just going to introduce our next speaker, Sanza Kazadi of Kazadi Enterprises. Sanza, come on up.
Okay. So we all know that we need cooling systems for our modern life. They keep our food and medicine safe. They keep our bodies from overheating. But for all the good they do, cooling systems are silent villains because they produce 3 times the carbon dioxide emissions of shipping and aviation combined. And the refrigerants that they use are up to 3,000 times more potent as greenhouse gases than carbon dioxide. So all of these emissions generate more and more heat on the planet. More heat generates more need for cooling, and more cooling generates more emissions. And we're caught on this vicious cycle as the world gets hotter and hotter and hotter. For me, this became personal when my mom moved into that house in the Democratic Republic of Congo, in a part of Kinshasa that's unincorporated and has no services, no electricity, no gas, no running water, no paved roads. That house is an oven, concrete walls and a metal roof. During summer days when it can be 100 degrees outside, it can be 20 degrees hotter inside. And I worried every day that she lived in that house that the heat would be just too much for her. I wondered if there was a way in which I could provide her with cooling, which didn't need electricity and also didn't need conventional refrigerants. Kazadi Enterprises has produced a patented technology that will do just that. The technology consists of 2 separate parts, which are connected by a salt solution. In part 1, we combine water with the salt solution, and that produces both heating and cooling. It also dilutes the salt solution eventually, so it can't be used forever. And we drain that salt solution and put it in the second piece of technology, which then recharge that salt solution by drying it out using environmental heat and airflow. We then put that salt solution back in the first device, and we can provide more cooling. Put these together and we can provide cooling anywhere where people can live. So our first product for the developed world is our refrigerators that go in in retail grocers. Our refrigerators will use up to 90% less electricity than conventional systems and use water as our refrigerant, so no greenhouse gas emissions from our refrigerants. Why retail grocers, you might ask? Well, first, it's a big market, $24.6 billion. But if you take a look at their financials, you'll see that retail grocers are barely hanging on. They have gross margins of 1.4 to 1.6%, so barely making it. And if you compare that to their cost of electricity for their refrigeration, you find that if you can reduce that cost by 90%, then you can increase their margins by up to 60%. So I'm going to let that sit for a second. Change one appliance and you increase your profits by 60%. That's a great opportunity for them, and that's a great opportunity for us. So here's how we're going to make money with it. There are two different ways in which we intend to make money. As I said, there are two parts to our technology. The first part that does the cooling. We'll license that part to partners like B Medical Systems, which has already shipped us one of their refrigerators so we can upgrade it. And that'll generate licensing revenue, which can help us stand up our company. The second part, which uses our second part of technology, is our regenerators, which regenerate the salt solution. Every time a refrigerator will be installed, a regenerator will be co-installed with that refrigerator. And once that is installed, we'll be able to tell how much energy these users are using, and we'll be able to bill them accordingly, providing us with a continued revenue source. It'll eventually become the biggest part of our business. Beyond that, our technology is actually a platform technology, which has lots of different uses. So once we've stood up our refrigeration technology, our refrigeration business, we anticipate moving on into heating, electrical power production, and water purification, all equally large markets for us to get into eventually. To date, we have 4 patents issued and 2 more pending. We've had technical validation from Chain Reaction Innovations and the National Science Foundation. We've been in a number of different accelerators, most recently the M-Hub Accelerator and Venture for Climate Tech. And we have a number of funders who are supporting us, including Longjump, Invenergy, Evergreen, and Nicor Gas. We've just recently increased the size of our team. Our newest team member, Nick, is so new, we don't even have a picture for him. We're planning a raise starting in August this year, $4 million to expand our team a little bit more, to execute our first licensing agreements and pilot projects, and also to develop our production for our regenerators. For me, the story always comes back here to my mom, who needed that cooling system, and there just wasn't a solution. Around our world, as the world warms up, we're seeing that this story is becoming more and more common, not just in the developing world, but also in the developed world. Our company intends to be that solution. My name is Sanza Kazadi. Thank you for listening. Please join me at the booth.
Great job, Sanza. Thanks for sharing your story. And Sanza's been a really great part of our cohort. I just want to tell everyone a quick story because he's just so supportive of everybody he encounters. So supportive, in fact, that he volunteered to speak to my daughter about her college choices over the last summer. She's just completed her first year of college this year, but he took some time out of his day and spent probably almost 2 hours talking to her because she didn't know what direction to go in. Those are the kinds of people in our program, and I just love it. So thank you, Sanza, for that as well. Our next speaker is Niall O'Dowd with Phase 3D.
Hi, everyone. Thanks for attending LEEP Day. I'm here to introduce Phase 3D and tell a story about how we're enabling the next phase of metal 3D printing. So additive manufacturing or metal 3D printing is in a pivotal phase. Companies like SpaceX and Toyota are pushing the industry from prototyping to end-use production. SpaceX, for example, is aimed to print 2 rocket engines per day, and Toyota has invested millions of dollars to produce production parts for the first time. These adoption verticals are pushing revenues up into 30 billion projected by 2030. And when I imagine the future of manufacturing, I think of a lights out facility, fully automated, parts coming out with high quality guaranteed every time. But in reality, AM is pretty immature at this stage. High scrap rates and no quality standards are preventing that transition into massive production. But that problem will be solved, and with quality and reliability updates and upgrades, we can achieve that future of manufacturing in a lights out production facility and really reach that massive market. And so from a customer perspective, we've heard about these quality and reliability challenges. Honeywell Aerospace told us they scrap over 40% of their parts, which is astronomical if you think about the bottom line impact. They're not alone. Morph 3D, another aerospace production company, the ex-CTO told me that he scraps easily 40 to 50%. It's not just aerospace industry, it's the medical industry, oil and gas, defense, even the automotive industry. They've all validated that they have lots of scrap and they lose hundreds of hours of print time because the quality and reliability issues in their printers. And so that's the challenge we're solving. We've invented a system called Fringe, which is a quality inspection system. It provides real-time monitoring, a rich data set, and a post-build report to solve those reliability issues, scrap parts early stage instead of waiting till post-production. Our product addresses three main value propositions, starting with a reduction in lead time of up to 50% for aerospace components. Historically, we've been de-risking technological development with powerful partners in the United States. We've been granted over $1.4 million in contracts from the US Air Force to solve their challenges involving reliability and quality issues during the printing process for aerospace components. The Department of Energy is interested in our technology to solve their challenges with a nuclear component production. NASA is co-developing our system to do quality inspection for their copper printing at NASA Marshall Space Flight Center. And those 7 companies which I mentioned earlier, they're all engaging in our paid pilot, which means that they're early adopters in this space. It means they're putting their money where their mouth is and choosing our technology to address this challenge. This is how we're planning to enable the AM production market. Today, we have multiple paid pilots. We've invoiced a large amount of money in the R&D phase of our technology. We've integrated directly with a metal 3D printing company. We've integrated with a forefront additive manufacturing software company. And we're looking to grow our company to reach steady state by the end of 2024. Then expanding to adjacent markets, and finally working with quality industry standard organizations like NASA, ASTM, ASME, to really enable that high quality requirement for all of these major manufacturing verticals. That investment has really supported our team. We have 6 full-time employees who are working hard. They span additive manufacturing experts, sensor technology experts, software developers. And so our ask today, we're announcing our seed fundraising round. We're looking for an investment of $2 million to really build that technology sales team, as well as establish a support network in the US and Europe, and also an opportunity to share our vision for expanding the total market by 3x with more aggressive investment. Thank you.
Great job, Niall. Thanks for that presentation. I haven't seen Niall much in the last few months. He's been so busy. So it was good to see him today. Our last presenter, certainly not least, is Claudio Bucher with Piersica, and he's going to come up and talk to you about batteries.
They tell me they keep the best for last, so I hope I live up to it. So Piersica is a battery technology company, and our company thesis is to transform the commercial lithium-ion battery. What moves the needle for adoption of a new battery? Well, that is the energy density of the battery. That's the most important parameter. And for the commercial lithium-ion battery, it has increased steadily in the first 20 years or so. But now the energy density is plateauing. And the industry is scrambling for the next technology that can move the needle even further. As you may know, lithium-ion battery is a very rich space, over $100 billion in 2023 and growing rapidly. So we want a piece of this pie. Our PRCCA's mission, our mission company thesis is to revolutionize the battery chemistry. So we are introducing new materials, new cell components, and we can go beyond the conventional limits, the limitations of the conventional battery. Let's put things in perspective. Let's compare everything to the energy density of a drivetrain for cars on airplane powered by combustion, and that is that box. And let's compare battery chemistries to this energy density. The lithium-ion battery is still about half the energy required to enter this box. The next generation battery is based on silicon anodes, and this is barely bridging this gap. So in order to have a battery system inside this box, the industry believes two technologies are required. One is lithium metal anodes, and the other technology are solid electrolytes. And these are the two core technologies for our company. And based on these materials, we have cell designs for nearly triple the energy of conventional lithium ion. There are many other players in the space. It's a busy space. However, all the other players use outdated materials. They use commercial materials. And frankly, every one of these companies can purchase each other's materials and develop them independently. For example, the only battery company that introduced a commercial solid-state lithium battery for EV applications is called Blue Solutions. They use a material, a polymer invented in the early 70s, discovered in the early 70s. Other players in this space, Solid Power, Prologium, QuantumScape, they also use commercial materials, outdated materials. And there are significant limitations to how much energy density can be obtained with these batteries. We feel that we are the only players in this space which introduces a new material, such that we are not bound by these limitations. This new material is a new conductive polymer. It has much higher conductivity than everything else on the market. It is much lighter, much cheaper, much higher safety because it doesn't require liquid electrolytes, and much cheaper. I've said that twice. It is fully back compatible with conventional lithium ion. It can be used as binder in existing commercial battery, and we use it to develop our solid separators from this material. And this type of results have been tested successfully externally by Argonne National Lab. How does it fare in terms of cost? Well, if you look at the green line here, in terms of dollars per kilogram, it's about 6 times cheaper than conventional separator and liquid electrolyte. And in terms of cost per kilowatt hour at battery level, for a battery made around this material, it can be less than half the cost of conventional battery. So significant numbers here. In terms of business and marketing, we are currently entering the prototype development. And at this early stage, we want to license our early materials to de-risk the success towards pilot. As we enter pilot manufacturing, we want to feed into small markets such as wearables and electronics. And as the technology matures to larger manufacturing scales, we want to enter more commodity markets such as EVs, and as well as new markets such as long distance electric flight, which is currently impossible to do. The company raised $1.5 million in 21 from venture capital groups. In 22, we won 4 grants for an additional $1.5 million, and we are wrapping up a $2 million round now and a $20 million valuation. We have 3 horizons, separator and anode, and we are entering now the prototype phase by putting these 2 technologies together into Horizon 3, which is cell development. The grants come from the Department of Energy, National Science Foundation, the Army and the Air Force. The polymer is manufactured at a company called Centonics, and we do testing at Florida State University as well as Argonne National Labs. We have a very experienced team. We all have deep roots in the battery space and chemicals for battery. We're not an academic startup. And you can see some of the executive team members here. To sum this up, we develop substantial technology, new materials. We always have very prudent use of capital. We think that we can run everything very cheaply and very lean. We always raise money at reasonable valuation. I'll be glad to discuss more with investors about this. And we have strong patents to protect our inventions, especially the polymer. And we already see significant monetization for this invention, which is the polymer, at this point, even regardless future development toward our cell. Thank you.
Thanks, Claudio, for rounding out our pitches from Chain Reaction Innovations. I think everybody did a great job. One thing I learned from Claudio is that Piersica means peach in Romanian. If you want to know why, you should visit his booth. Thanks, everyone. With that, I'm going to introduce our next cohort of presenters, and Melanie Sonsting from Cyclotron Road at Berkeley Lab will be the one to introduce her cohort.
Hello, everyone. As Dina said, I'm Melanie Sonsting. I'm program manager at the Cyclotron Road program at Berkeley Laboratory. I wanted to tell you a few things about our program and then introduce the people that we're really here to talk to and hear from. But our program was the one that was founded in 2015. And so I have the great honor of representing the first distinction of being the first LEEP node here. And it started out with seed funding from Lawrence Berkeley National Laboratory, as well as the Advanced Manufacturing Office. And we've continued to be supported by advanced manufacturing offices in a sustained way, as well as a number of other federal and private partnerships. So being the very first LEEP node and then having a lot of other LEEP nodes, sometimes we've talked about maybe changing our name to the mother node, but it turns out that that really doesn't fly in mixed companies. So we've stuck with Cyclotron Road, which is in itself a very unique name. Part of that is because we were trying to think of how do you concisely say, you know, this is really hard tech science, like cyclotron. There's nothing harder tech than a cyclotron. And then road is the road from academia to hopefully a successful market. So that's where we got our name, and we're very proud of it. And our secret tagline is the mother node. I'd also like to highlight 3 things that make this program very special. One of them is our partnership being founded in Berkeley Lab. We have access to world-class scientific facilities, amazing professors through UC Berkeley, and many just stellar scientists that are there to provide technical mentorship and scientific expertise and access to hard tech equipment that they wouldn't otherwise be able to get to. We're also very grateful for our collaboration with the nonprofit Activate. They partner with us for the full 2 years of the fellowship to provide hands-on, high-touch, weekly entrepreneurial and business mentorship to the teams. And those 2 things together, we thought were going to be the most amazing thing ever, but it turns out there's a third part of it that makes it incredibly special. And that's the people that we've been recruiting and the people that have been applying to the program. After 8 years of having alumni continuing to be involved in our community, continuing to contribute to the Slack channel where all of the fellows who are coming in can hear from the ones who have left, we found that that's actually the third leg of the stool that really gives the program lasting benefit, is the community of entrepreneurs that are really have grown to rely on each other. So very proud of that. And I'd like to now introduce them. We're starting off with Kezi Cheng, CEO of Flow Materials, where she's been working on fully circular polymers enabling circular design.
Hi, everyone. My name is Kezi, and we're Flow Materials. We're a sustainable materials spin out from Lawrence Berkeley National Lab, where we commercialize infinitely recyclable polymers, and we're bringing those to market. So we incorporated about 2 years ago, and thanks to the support of DOE as well as Cyclotron Road, we've been able to gain funding and lab access. We're currently based in Berkeley, where we formulate our polymers, scale our materials, and do product development. So we're going to talk about plastics today. Plastics is one of the greatest inventions of the last century. It is useful, it's durable, and it's cheap. But humans have become addicted to plastics, and there's no easy fix for that. In the past 30 years, plastics consumption has quadrupled, where we're now producing 400 million metric tons of plastics, of virgin plastics per year, which accounts for over 3.4% of global greenhouse gas emissions, and it has detrimental effect on our health and well-being. So if the problem is so big, why are only less than 10% of plastics currently being recycled? And I want to point out that it's important to note that plastics were never designed to be recycled, and the current recycling solutions we have for them are not sufficient. These are just a few examples for why they're not. Currently, large-scale recycling facilities require high energy, high temperature, and catalysts. In addition, performance degradation is seen commonly in mechanical recycling as well as chemical recycling. And not to mention, there is a ton of take back and reverse logistics issues involving collecting and sorting of contaminated and complex materials and products at the end of life. And also the lack of material transparency and traceability throughout the supply chain makes the whole thing even more difficult. And I would like to say that probably the most important factor for why recycling is so low right now is because recycling isn't profitable. As you can see, plastics recycling is both a materials problem and a business problem, and these cannot be decoupled. At Flow Materials, we're commercializing the technology platform and the circular logistics to make recycling profitable. So we're going to dive into what we do on the technical front first. So at Flow, our core IP is a new material called PDKs. It's polydiketoenamines. It is a vitromer resin made from carboxylic acids and polyamines. It's developed at Berkeley Labs, and what's great about this material is that it can be chemically and thermally reprocessed indefinitely at low temperature and in mixed waste streams. So what we can do is we can access polymer to monomer recycling in a catalyst-free condition at room temperature. The dynamic covalent nature of these materials also allow them to be thermally reprocessed for an innumerable number of cycles to preserve properties after each mechanical recycling. What's also important to note is that we can access chemical recycling, and in the process of accessing chemical recycling, we can not only separate our material out from a mixed waste stream of materials, we can also remove additives from our material, plasticizers, as well as contaminants, which helps with the contamination problem that we see so much at the end of life. I want to talk about the economic incentive for our material. We create value by taking recycled materials back. And the reason for that is because our recycled materials are 20x lower in cost and 40x lower in carbon emissions than our virgin materials. So we're incentivized to do that. But this only works if we're both the supplier and the recycler, which brings me to logistics. Our recycling process can be modular. It is low energy, requires room temperature in low acid solutions. And we're able to do on-site recycling spokes that simplifies logistics and shortens the supply chain. In a linear economy, value diminishes throughout the supply chain. In a circular economy, value is preserved. And Flow is an important player in the circular supply chain that you see on the right here. We need to be both the material producer as well as the recycler to be responsible for the materials that we put out into the world, and incentivize our partners and customers to work with us by providing them with low cost and low footprint solutions. So where do we start? It's a material platform and we need to start somewhere. And we're starting with eyewear. And the reason we're starting with eyewear, just quick background, eyewear is made of cellulose acetate. So it's technically a bio-based material, and it's compression molded into sheets that's subtractively manufactured into frames. And the reason it's a great beachhead for Flow is because currently there is a high degree of waste in the manufacturing process. To create one pair of frames, you generate about 80 to 90% of waste in the subtractive CNC machining process. That accounts for 250,000 tons of waste per year that goes to landfill currently. We can solve this problem. What's also great about eyewear is that we've demonstrated through our LEEP program that we can fit into the existing manufacturing techniques as current acetate. So we can not only tap into resin to sheet compression molding, but we can also tap into the CNC machining of sheet to frame. And I also want to bring up the market opportunity. 1.5 billion plastic frames are produced each year at $20 to $40 per sheet material, per kilogram of sheet material, which we can actually achieve price parity with currently. That's a $4 billion serviceable addressable market just in providing sheets of materials to eyewear. Also, for anyone wearing glasses here, if you want to take off your glasses and check where it's made, I can almost be certain that it's not made and manufactured in the USA. And since the start of our program, we have demonstrated minimum viable products. And in my hand are infinitely recyclable eyewear made from PDKs and made and manufactured in the USA. So we've made a lot of progress since the start of our fellowship, but we still have a long way to go. We're raising a seed stage in 3 months to ramp up PDK production, to secure pilot partners, to demonstrate the circular logistics of eyewear, and then also to demonstrate that our material platform could be expanded to other products and verticals like fibers and foam. We've grown our team since the beginning of our fellowship. And we've also assembled a team of experts in vitrimers, in specialty chemicals, as well as in eyewear. I'm super grateful for the support, the funding from Department of Energy and Cyclotron Road. And I just want to end on that. We are building this plastics from the future. And our mission is to accelerate the transition to a zero waste economy by making plastics recycling more desirable, more efficient, and more profitable. Thank you.
Thank you very much, Kezi. I'm going to need to borrow a pair of your glasses to actually read what is written on the inside of mine. I don't know if anybody else had that problem. Next up, I would love to welcome to the stage Antonio Backlig, founder of InLight Energy. And he's going to tell you about developing affordable grid batteries from iron and salt.
Hi, I'm Antonio Backlig. I'm the founder and CEO of InLight Energy. Let's talk about energy storage on the US electricity grid. In 2020, we had 23 gigawatts of energy storage installed, most of it pumped hydro. By 2050, we need to install over 1 terawatt of energy storage on the grid, meaning the US alone will spend trillions of dollars installing energy storage. We need to spend this money on the optimal technologies that we can manufacture here in the United States. Lithium-ion batteries, excellent for electric vehicles, not the optimal technology for grid storage because of their materials cost, the resource availability, and supply chains foreign controlled, safety with fire risks, and a lifetime that is not up to utility assets. That's why we're working on the salt and iron battery, which is made of abundant materials we can source domestically, has a long 20-year lifetime, has high round-trip efficiency, is safe with no fire risk, and has a competitive energy density. Now, we care about all of these things, but if we had to choose one metric to focus on, that would be levelized cost of storage for a particular application. The application we're targeting is diurnal grid storage. That's 4 to 10 hours duration. For that application, what we care about are very low materials cost and very high round trip efficiency, which is the energy out divided by the energy you put in. So we want to be in the right-hand corner of this chart, and that's why the salt and iron battery is the optimal technology for levelized cost of storage for diurnal storage. So why hasn't this been done before? Well, the answer is, in part, it has in some ways. The salt and iron battery was first developed in the 1980s by a team called Beta Research. But by the 90s, they had switched to the nickel chemistry because they were optimizing for acceleration for electric vehicles. The salt and nickel chemistry, also known as the Zebra battery, is fully commercialized. It's been deployed, it's been proven in multiple different applications, but it's stuck at a high cost point because of its relatively low volume manufacturing. So before I talk about how we solve this problem, I just want to make a brief aside about this team, Beta Research. Beta Research, as I said, they originally developed the Zebra batteries in the 80s, and they've been at the forefront of them for the last 40 years. And when I was in graduate school, I used to read papers by them and wished I could benefit from their deep expertise. So I'm happy to say that during the LEEP program at Cyclotron Road, I was able to meet the team at Beta Research. And not only that, I was able to convince them to join me. And we did that by Enlight Energy acquiring the team and facilities at Beta Research, which we closed last November. There's all different routes to a startup. So together, we are going to optimize this battery technology for levelized costs for the grid rather than for acceleration for electric vehicles. And what does that mean? That means that we're taking the current generation of cells, which were optimized for acceleration, and we are making a next generation of cells, which are much larger, and therefore will have a much lower manufacturing cost. And we're going from nickel to iron, which will greatly reduce the materials cost. And so to put some numbers on that, the historical nickel batteries, there's been 3 factories made in the world for those. At that factory production rate, their costs are over $500 per kilowatt hour. But with our new design, by going to a larger cell, larger modules, going to iron instead of nickel, our first factory will be at $100 per kilowatt hour at the same manufacturing scale. And then as we continue to scale up to gigafactories, we will achieve our long-term cost target of $30 per kilowatt hour manufactured modules. So how will we get there? So first, I want to thank Cyclotron Road, the Activate Fellowship, Berkeley National Laboratories, and the ARPA-E seed grant we received for helping us to get to where we are today. We would not be where we are today without them. And we are optimizing our larger cell design. The next steps are to use our existing facilities that we have through the acquisition that has a pilot manufacturing line that can make 6 megawatt hours per year of batteries to deploy utility scale pilots of these batteries, and then to make a US-based factory that can manufacture on the scale of gigawatt hours per year. So we're Enlight Energy. We're making a next generation salt and iron battery for grid storage. And for any investors out there, we are closing our seed round this month. We have a lead investor, so if you're interested, please talk to me. Thank you very much.
Thanks so much, Antonio. And I hope people do go and talk to the innovators afterwards. Stick around for the demo day. Antonio is a great person to get into deep philosophical engagements with. Next up, I'd like to introduce Aaron Hall, CEO and founder of Entropic Materials, where they are working on a truly compostable plastic for a circular bioeconomy.
Hello, everyone. It's wonderful to be here. I'm Aaron Hall, founder, CEO of Entropic Materials, and I'm going to tell you a little bit about the work we've been doing over the past couple of years. So Kezi mentioned much of this in hers, so I won't belabor the point, but we've produced over 7.3 billion tons of plastic since the 1950s, and 86% of that has become waste. That waste pollutes our land, our oceans, it's in our bodies. And frankly, 86% waste is an entirely unacceptable metric. We have to do better. And we can't just stop making plastic because plastics are a central part of our modern economy. They touch every single product category that you care about. And that could be electronics, consumer products, food, medicine. I don't want to go back to a world pre-plastic, and I don't think anyone in here does either. And that has led to them being an over $600 billion industry. Now, plastics are made of polymers, and in nature, polymers are found everywhere, be it cellulose in vegetables, chitin in crab shells, or cheese and gluten in macaroni and cheese. And so backstory, I was a chef and a food scientist before I got into materials. So everything to me comes back around to that for analogy. And we don't worry about these materials polluting our environment. And why is that? Well, that's because there exist these macromolecules in biology that are called enzymes, and those enzymes are evolved to break down these polymers so that those small molecule products that get produced can be recirculated and brought back into the system to nourish our bodies, to nourish nature. And it's a very nice system that it would be wonderful if we could emulate. But enzymes are evolved to be in cells, and that is not inside of plastic, that is not inside of manufacturing environments, and that is a pain point. And that is where we come in. We are commercializing a breakthrough enzyme stabilization technology that allows us to encapsulate these enzymes in what I like to call PPE for proteins, that lets us put them inside of the materials and use them in foreign environments to leverage their abilities. And so if we take your standard compostable plastic and we think about putting it in a compost pile, what would happen naturally is enzymes that are in the soil, that are from microbes, would land on the surface of the plastic. They would randomly cut the chains. It would lead to the production of microplastics. And it's a very slow and inefficient process that can take months or years to actually break down the plastics. What we do is embed enzymatic particles directly inside of the plastics, which enables us to trigger them at the end of life to then break down in days to weeks. And what's really exciting is that a unique feature of our system is that we're actually proceeding through a different degradation mechanism that starts at one end of that chain and breaks it up monomer by monomer. So at the end, we don't actually produce any microplastics, which is really exciting. And this is not just a paper phase exercise. This is something that we've actually published in Nature and we are currently scaling. On the left, I show a polymer film, and I'd love for you to come back to the back of the room later and see some of these. And over just a couple of days in a compost-like environment, we get dramatic change in the material properties. It becomes fragile and brittle, and they fall apart within your fingers. And we've shown this with both PCL as well as PLA, which I'll talk a little bit about more, and we intend to expand to a wide variety of plastics over time. We can also get this degradation, thanks to the enzymes being inside, in a warm water environment. And that's really exciting because those environments are simple infrastructure that's very easy to scale or decentralize, which is really important because, as Kezi mentioned, we don't have enough infrastructure today. And that opens up the opportunity to do chemical recycling of those small molecules to repurpose them for new plastics or other application spaces. And I want to urge and highlight the fact that we're actually stopping the microplastics at the source here, which is a key differentiator from many of the other approaches that we've seen. We're formulating this to be a drop-in additive into the existing manufacturing streams to minimize the cost. This makes our material more scalable and easier to get in. We use a very low usage level, 1% or less. I think we can actually bring that down a few orders of magnitude, which of course means we can have more orders of magnitude of impact with smaller volumes. And of course, the degradation is on demand, which is really important because we don't want our products melting on shelves. That would create a big mess. We're targeting PLA as our first market. This is a very exciting part of the market. It's the most common compostable plastic, as well as one of the fastest growing segments in the plastic industry. And we've chosen that for a few specific reasons that we learned during our customer discovery and through support from the Activate community and the Cyclotron Road community. One being that we can expand the product design space, which is really great because we want to grow pies, not just capture fractions of ones that are already existing. You can also disconnect the degradation performance from the design, which means we can overcome some regulatory hurdles. And of course, there are environmental impact benefits that are very important as well. And I want to highlight as well the fact that we are also a platform technology. Enzymes do not just the breakdown of plastics and foods, but a whole host of interesting reactions. And we're looking forward to exploring those as well over time and being a partner to this biotech revolution that we're going through. I've gone from a solo founder to having a team of 5. One of them's not up here because he just started. And they're at the lab right now working on scale up and de-risking so that we can get our first commercial pilots going this year. And finally, I'd like to say thank you to all of our sponsors, in particular DOE, AMTO, for supporting us. I was a straight out of PhD program student who had never started a company before, and the immense mentorship and support from LEEP and Activate and the investors that came on board has just been absolutely phenomenal and has really transformed me from a bench scale scientist and former chef to now a CEO and entrepreneur that's working on a really huge problem. And so with that, I say thank you for your time. I look forward to talking to all of you, and I really appreciate all the support. Thank you.
Thank you so much, Erin. Next up, we're going to have Fatma Kaplan, CEO of Ferronym, where they are working on an effective, sustainable biocontrol.
Hi, everyone. I'm Fatma Kaplan, CEO and founder of Ferronym. We use a new kind of pheromone to control agricultural pests in the soil so farmers can grow more food. Agricultural pests cause significant crop losses globally. Farmers spend $60 billion annually to control pests. Concerns with the toxicity and environmental impact of traditional chemical pesticides have resulted in regulation and outright bans. This left farmers in need of eco-friendly solutions. Biopesticides provide eco-friendly solutions. They're environmentally responsible, climate-friendly, and safe for farmers. And they are the fastest growing market. There are two kinds, microbials and biochemicals. We focus on pheromones. Depending on the type, biopesticides have different limitations. This provides a lot of opportunities in this market. Insect pheromones are very effective, but their applications are limited to mating disruptions for above ground pests and no seed treatment applications. Our solution is a new class of pheromone from microscopic roundworms called nematodes. I identified the first mate-finding pheromone from model nematode, C. elegans, and published it in Nature in 2008. USDA recruited me to apply this new knowledge for agriculturally important nematodes, where I found pheromones control other behaviors in other nematodes. This provides us opportunity to control all nematodes. We are unlocking the potential of pheromones in the agricultural pest control. We can control all nematodes, both good and the bad. Because these pheromones are water soluble, we can store them dry and store them as dry powder. This provides seed treatment application. We can control multiple pests in the soil. They are a very good alternative to climate-friendly alternative to soil fumigants, which are greenhouse gas emitters. We have two opportunities. Our first application is Nemastim. It is a pheromone treatment for beneficial nematodes, which are used as a biocontrol agents to control insect pests, but suffered from limited effectiveness. Nemastim makes them better biopesticide agents. With the third-party trial with the USDA, we demonstrated Nemastim improves efficacy of beneficial nematodes in orchards against pecan weevil. Our second application is Ferricode. It's a seed treatment. It protects the seeds from bad nematodes that attack plant roots. Ferronym has a very unique position in the agricultural pest control ecosystem. Our product targets the pest in the soil, where existing pheromone companies' products target the pest above ground. Our product improves effectiveness of other biopesticide companies' products, and that makes them potential partners. We also have a unique seed treatment application. There is a strong demand for pheromone-based products. Currently, we are executing our sample testing agreements with commercial partners. Our first agreement moved to second phase to field trials. Our team has a domain expertise, talent, and relationship to bring Nemastim and Ferricode to the market. We developed a scalable manufacturing method using fermentation with the Activate Fellowship Program and Cyclotron Road program providing us facilities at ABPDU to scale up to 300 liters. We are raising $5 million in the fall to build our team and scale up our manufacturing to pilot. We thank Cyclotron Program for providing us facilities to scale up and activate for their mentorship and the community. Thank you.
Thank you so much, Fatma. For our last speaker, I know we're running a little bit over time, so I'll make it short, but the previous 4 people are all in our graduating cohort 2021. You are now going to get to see a preview of the 2022 cohort member, Daniel Sun, who's CEO and founder of SunChem, where they are working on precision separation of critical metals.
First, I would just like to thank all the organizers for organizing this awesome event, and I'd like to thank all of you here. So as Melanie said, we work on the precision separation of critical metals. Now, I would argue that the separation of metals is both of environmental and economic significance, and we're developing nanofiltration technologies that can selectively target different critical metals. For example, copper and gold used in every modern day electronics. Heavy metals, bad if consumed, very toxic to our bodies. Platinum group metals, very valuable, used in a lot of catalytic applications, as well as rare earth metals used in a lot of defense and optics applications. And then there's the energy relevant metals used for energy production and energy storage, clean energy production. But for our first beachhead market, we'll be focusing on gold and copper. So there's actually a lot of sources of gold that is quite unreachable. For example, electronic waste. The United States produces 9 million tons of electronic waste, but we only recycle 25% of it. There's actually a lot of industrial situations that have trace gold in their effluents, and it's just discharged into the environment. And even the ocean contains 20 million tons of gold. But in all of these situations, there's a little bit of gold and a lot of other stuff. So it's really difficult to selectively extract gold from these sources. Well, our filter devices can reach those sources. So if you have gold dissolved in a liquid and you pass it through our device will selectively concentrate it, and then we can make 24 karat gold in the back end. And really, the magic to our filter devices are the materials that we synthesize. At the nanoscale, we can link together organic ligands, linked together by metal ions and clusters, have them propagate in 3 dimensions in a highly ordered manner, and create these essentially nanocrystals or crystallites in solution, as seen here. So essentially, they're just powders. But what makes these powders so special is that they're the most porous materials in the world. A gram of this powder can have the internal surface area of an entire football field. So you can imagine you can absorb a lot of stuff. So all we do is use our proprietary chemistry to paint the walls of these pores with critical metal scavenging polymers that are selected for, say, gold. So if we look at some results, we can actually extract gold, 99% of it from solutions in less than 2 minutes. It's extremely fast. But even more interesting, we have this unprecedented selectivity. So the initial concentration is the gray bar. The green bar is after treatment. And for all these metals, we don't pick it up, but we only pick up gold in the back end. We see this technology in first a quick market, which we believe is electronic waste recycling for gold and copper, but also our gold mine market, no pun intended, for mining operations and companies that employ gold. Now, this target market is worth about $130 billion with a compound annual growth rate of 7%. And after talking to a bunch of customers, we've received some letters of intent support from different mining operations, as well as electronic waste recycling centers. And what we've learned is that it costs about $33,000 to produce a kilo of gold, a ton of activated carbon to produce 8 kilos of gold. Because our materials are so porous, we can make it 5 times cheaper and use 100 times less material. Now, here's our filter device. We have a water source containing trace gold. We're pumping it through our device, and then we're measuring the concentration afterwards. And this is 0 to 100% the initial concentration. As you can see, all of these metals pass through. That means the device is not extracting those metals, but we don't see any gold in the back end. So that means that the device is indeed selectively extracting and concentrating the gold in this small volume of space. And then we can turn that into 24 karat gold. As of today, the team has concentrated 2.5 grams of gold from about 65 gallons of water. And if you're interested on what we're going to do next, please stop by the booth. So I just want to reiterate that we are not a one-trick pony. We can actually tune our systems to be selected for other metals, for example, lead. This right here is ocean water. Ocean water is the most complex matrix in the world. And as you can see, sodium is 14,000 times the concentration of lead, but we only pick up lead. And we can decontaminate lead in less than 60 seconds to drinkable levels. Now, I know it's in my team's heart and my heart as well, that it's near and dear to our heart that we want to be part of the humanitarian effort to provide clean drinking water to people, but this endeavor will be pursued down the line. We're based out of Lawrence Berkeley National Lab in the beautiful San Francisco Bay Area. If you're out there, please come visit us, come visit the lab. And I just want to reiterate, this is a team thing. I want to thank the team, especially Dana, Emily, and Ashton. Seriously, thank you so much for all your hard work, as well as our diverse group of advisors and collaborators. Last, I would like to thank the U.S. Department of Energy's Advanced Manufacturing offices for supporting myself and giving me the opportunity to work on this. Activate and Cyclotron Road, for their mentorship and the development of me as a next entrepreneur, National Science Foundation, and then also LBNL and Molecular Foundry. Thank you so much.
Thank you so much. As you can see, we have amazing fellows, but there's so much more to come. So I'd like to introduce our sister site. We've got Dan Miller from Innovation Crossroads. Come on up and tell us about your teams.
All right, thanks, Melanie, and wow, what great pitches and presentations from all these fantastic innovators. Before we get to the Innovation Crossroads innovators, I'd like to take a moment and echo the appreciation for the Department of Energy taking a leadership role in innovation by supporting these fantastic innovators through the Lab Embedded Entrepreneurship Program. I mean, that's the main reason we're all here today. So thank you again, DOE. I mean, at Innovation Crossroads at Oak Ridge National Lab, we're fortunate to have another partner who is passionate about energy and clean tech startups. The Tennessee Valley Authority has been a sponsor of Innovation Crossroads since 2019. But more importantly, they've been an advisor, mentor, and collaborator since our program was founded. So thank you, Geri and Miles, for being a great partner and for being here and supporting our program. And then finally, I'd like to recognize my colleagues at ORNL who are here. Kelly Wampler, who is an operational wizard, to say the least, as everybody in our program knows. And Mike Paulus, who's the ORNL Director of Partnerships, who keeps us out of trouble as much as possible anyway. So now let's keep things rolling. I'd like to introduce Shuchi Khurana with AdiGuru. You may know him better as SK.
Thank you, Dan. And many thanks to all the directors also who run these programs, right? It's not easy, as somebody was pointing out today. I think Joe was pointing out this morning. So thank you, Dan. And I'm still learning the names of other directors. So thank you, all of you as well, and the team. My name is Shuchi Khurana. I go by SK, and company name is AdiGuru. Adi comes from additive manufacturing, and Guru comes from the fact that we are creating an intelligent software solution for additive manufacturing. So Niall set the stage a little bit earlier. He talked about metal additive manufacturing market. We are looking at the whole additive manufacturing market, which is growing, which is even bigger. It's going to be about $50 billion by 2027. It's growing very fast, and within that, monitoring of additive manufacturing technology is going to be more than $1 billion market in a few years. Now, again, Niall in his presentation set the stage. He talked about 40% defect rate in metal additive manufacturing, and that's absolutely true. You won't find it published everywhere, but people talk colloquially, and he had a couple of quotes there. and I can attest to that. So what happens is you make the part. For example, these are examples of very expensive $20,000 fuel jet nozzles. You make the part, they may go bad, so you have to X-ray scan each and every part. Overall, with all the defects and X-ray CT scanning, you're wasting more than $2 billion a year, at least, if not more. The solution is real-time monitoring, where you can do a real-time monitoring of the parts using different sensors and artificial intelligence, and stop these failed prints in real time, and then save a lot of time and materials. So you can save more than $3 million a year per customer on an average. This is our long-term vision. And this is what we are creating and commercializing as of now, is use computer vision, bring data from different sensors, combined with artificial intelligence, physics-based modeling, our knowledge of process, and identify these defects in real time. Each and every process has a different defect. There are different kinds of additive manufacturing processes. These are 5 listed here, and there are obviously many different kinds of manufacturing processes. So they have different defects, different issues, but we have a platform technology where we have a good user interface, artificial intelligence, machine learning techniques, and a good notification engine. We can bring data from different sensors, very modular technology. We can bring data from different sensors, different softwares, different machines, and then analyze different additive processes. And in the long run, even go beyond those. So, this is a quick example or screenshot of one of our, our software, which talks about machine vision that we use to detect defects in an additive manufacturing process. So we are very thankful for Innovation Crossroads, because 2 years ago, we were very far from commercialization. During Innovation Crossroads, we came through the beta phase, and now we are in the full launch phase right now. We have reduced our setup times. We have done integration with machines, brought in different sensors into our portfolio, for example, infrared sensors and the data from the machines itself. And we have multiple installs. When we started at Innovation 2 years ago, we had no installs. Now we have more than 10 installs. We recently announced a collaboration with Exact Metal. We'll be installing our software into their machines directly. That will be a great user benefit, because users won't have to switch between the parts producing machine and the software. And Open Additive is another machine maker and a sensor maker in the industry. We have installs at Northrop Grumman, Tinker Air Force Base, Army Research Lab, and many more places. We have also pilots and academic installs. We have been collecting data and getting feedback. So big thing for us is we are going to push hard this year for software sales and subscription. And obviously, we'll be continually improving the product and bringing in different sensor modalities into AdiGuru. What we ask for is we want to collaborate with our long-term strategy is to collaborate with the machine makers and as well as other software makers, including who might be in the room, as well as and we are always ready to talk to strategic investors who bring money and much more to the company. Thank you, and please come visit us.
All right, thank you, SK. We'll keep it rolling with Caleb Alexander from Daylight Batteries. Caleb.
Hi there. Thanks for coming out today, listen to all these great talks. Here I'm going to tell you about what we're working on at Daylight Batteries. So the problem we're trying to solve is essentially the fact that by 2030, lithium-ion batteries are going to be facing severe nickel and cobalt supply chain shortages. And that's going to make the batteries even more expensive than what they currently are. And then also, lithium-ion batteries are very heavy for various transportation applications as well. And so if we're going to transition the world over to renewable energy, a different battery chemistry is needed. So when looking for a new battery chemistry to help transition the world to renewable energy, the name of the game here is to minimize our dollars per kilowatt hour of storage. And that's not just at the chemistry level, but at the full pack level of the battery itself. So if you take this expression and multiply the top and bottom by the battery's mass, you can see here that the first term corresponds to the battery's material manufacturing costs, while the second term corresponds to the inverse of the battery's energy density, meaning the more energy your batteries can store, the fewer batteries you need to make and buy. So really what this means is the true name of the game here is to develop a battery that simultaneously minimizes our material and manufacturing costs while maximizing our battery's energy density. And so the solution that we're targeting is a sodium air battery that's safe from overcharging and thermal runaway. It's lightweight, being about half to a third of the weight of lithium ion batteries, depending on your operating temperature. And that fact, combined with the fact that sodium fills the oceans and oxygen from the air is free, means that this battery should be able to be made at very low cost. And so the key bottleneck for this material so far has been its Nasicon solid electrolyte, as shown here. And so Nasicon, it's a ceramic material, and it intrinsically has a very high sodium ion conductivity. But and normally you'd want to make it as thin as possible. But if you have a very thin ceramic, it's very brittle and can easily break, and no one wants that happening within your battery. And so you have to make it your solid electrolyte thicker, but now you've just created a large resistance within your cell, and now your battery can only charge and discharge super slowly, so it's not practical. So another approach people have tried is using polymer electrolytes, and polymers are great because it can be made very thin and flexible and therefore very scalable, but these materials tend to have a very low sodium ion conductivity, so you still have this charge rate problem. And so where we've come along is we've been able to develop a thin film Nasicon solid electrolyte that can take advantage of its high sodium ion conductivity while still allowing it to be thin and flexible, and then therefore very scalable. So we can have our cake and eat it too with fast charging. And so the faster we develop the sodium air battery, the faster we can help transition the world to renewable energy. And that transition would be incredibly valuable, on the order of hundreds of billions or trillions of dollars. But in order to access these markets, the batteries need to cost less than $30 per kilowatt hour for solar and wind energy. For EVs to cost the same as gas-powered cars, the batteries need to cost less than $120 per kilowatt hour. And if electric aircraft and drone delivery are really going to take off, the batteries need to store at least 400 watt hours per kilogram at the cell level. So previous battery startups that have come and failed before me tend to target these large volume, low margin markets, and we want to avoid that. So we're first going to target the electric aircraft market first, where they're willing to pay an arm and a leg for a lightweight battery, and then use that to scale up into these much larger markets. And so over the Innovation Crossroads program, I've built up a team of business and manufacturing and technical expertise and advisors. They're really great guys. Super blessed to have them. And just being a part of the Innovation Crossroads program here, we've been able to successfully demonstrate long-term stability coatings to significantly increase the lifespan of our batteries, especially in 58% sodium hydroxide solution. People thought that wasn't possible, but we did it. And as well as other improvements to our solid electrolytes and battery components to put all this together. And I've just had like so much support from the people in the Innovation Crossroads program. It's been a true blessing here. And so we're looking to raise a $2.5 million seed round to hire more engineers, more equipment, so we can speed up development after Innovation Crossroads. We're looking for talented engineers to join us, as well as partners with battery manufacturing expertise, and as well as large future customers to partner with as well. And so I'd like to give a special shout out to the Tennessee Valley Authority for sponsoring my fellowship, as well as the DOE and ORNL for just like getting this whole program going. Daylight wouldn't exist if it wasn't for this program. So like, thank you for everyone. Thank you. It's been a blessing.
All right. Next up from Innovation Crossroads, Cohort 5, I am very happy to introduce Philip Stuckey with FC Renew.
So FC Renew is developing a core technology, and we call it an oil change for your hydrogen fuel cell. So hydrogen fuel cells, when paired with renewable energy, are truly a zero emission electrification energy source. So hydrogen fuel cells fuel very conventionally the way we use gasoline and diesel fuels right now. You pull up to a pump, you connect the nozzle, and you deliver fuel. And one of the earth shots is the hydrogen earth shot, and that's 111. So $1 kilogram of hydrogen for $1 in 1 decade is the goal. So a passenger vehicle holds around 6 kilograms of hydrogen, meaning that your tank of fuel would be about $6 as we achieve that goal. But fuel cells themselves still have some technology problems to really gain traction in the marketplace. And they are currently limited by their lifetimes and durability. And 5,000 hours traveled is equivalent to about 150,000 miles for a passenger vehicle. And right now, the only paradigm that the industry has is to completely replace that fuel cell stack by removing it from the vehicle and putting in a new one, or refurbishing it, which actually costs about 70% of a brand new fuel cell stack anyhow. So we don't really have a great option for this kind of circular nature for hydrogen fuel cells. And fuel cells have really had successful demonstrations with forklifts and passenger vehicles, and definitely getting into buses and other medium duty applications. And we're now starting to see large Class 8 trucks going down the highway with fuel cells, ships and trains. And these are all great applications for fuel cells, definitely into the Million Mile Fuel Cell Truck Consortium, which is a DOE program to get fuel cells into large Class 8 trucks. And those Class 8 trucks require an ultimate durability of about 30,000 hours. So there's still a lot of, I think, progress that can be made to achieve that. So what is FC Renew doing to get there? Is what we're doing is we're developing a process to refurbish the electric catalyst in the fuel cell in situ. What that means is you no longer have to remove a fuel cell from the vehicle in order to actually refurbish it and keep it going. So we kind of paradigm it to an oil change because it's a maintenance event that periodically you bring your vehicle into the shop for maintenance. A trained technician will be able to then diagnose it, connect our equipment to the vehicle itself, perform our process, and then that vehicle is ready to go back out on the road so that it can be driven longer. And as that electric catalyst degrades, again, which is a process that's been well studied, we're able to do this process repetitively to extend the lifetime of hydrogen fuel cells. And so going back to that problem of swapping fuel cell stacks, if we look at the process, you still have to pay for your initial fuel cell. And I was at the DOE annual merit review yesterday, and our $40,000 projection for a fuel cell stack is a little bit low for these Class 8 trucks from what I saw. But you have to pay for your initial fuel cell. But our process at around $1,000 is quite a cost saving, and considering that you might have to swap a fuel cell stack about 6 times to make it viable for something like a Class 8 truck. And for these industries, total cost of ownership is really what drives the economics. And this is an enabling technology to help achieve electrification. So FC Renew right now is growing and hiring. We've been able to obtain about a little over $3 million now in grants and contracts. Most of that is still to come. We're active in a NSF phase 1, completed Army phase 1, have been selected for our phase 2, as well as the DOE phase 1 SBIR. And all that really is thanks to this program with Innovation Crossroads, which has enabled us to get our feasibility data, test out some of these ideas in the laboratory, and have those analytical tools needed to actually evaluate what we're doing to these fuel cell electric catalysts. So, and right now we are establishing our wet labs in Knoxville, not far away at University of Tennessee, where we lease wet lab space that Anna Douglas actually used to occupy. So following in some footsteps of some of our alumni. And also have to thank the state of Tennessee as well for some matching funds and sponsorships as well. So really a great place to get immersed in the ecosystem. So we are now at this point looking for additional industrial partners on that. We've identified 2 for our future SBIR work, as well as 1 academic research institution. But as we continue forward with our R&D, we will begin looking for funds to actually go out and complete our sales cycles and additional funding for demonstration. So I want to thank you all for your consideration.
All right, thank you, Philip. We'll move right along on the program and very proud to introduce Tommy Gibbons with Hempitecture.
My name is Tommy Gibbons. I am the co-founder and chief innovation officer at Hempitecture. At Hempitecture, we do something that's probably very familiar to a lot of you guys, but different in an important way as well. We manufacture and distribute insulation. Now, insulation's existed in our country and our buildings since before modern times, long before, but it's never existed in a way that you can decarbonize the insulation product. So that's what we do at Hempitecture. We specialize in decarbonized building materials. And why do we do that? Well, construction is actually responsible for 40% of embodied emissions in our economy. That's more than transportation, manufacturing, and other industries all put together. It's the largest single contributor. So it really, really is paramount that we decarbonize the building materials that we put in our houses. And it's not just choosing materials that are energy efficient, right? We've thought about spray foams, fiberglasses, mineral wool insulations. All these things can reduce the heating and cooling energy loads in your houses, but a lot of the carbon emissions in those materials actually occur before they're even installed. So that's referred to embodied carbon emissions. So you see on the left here, those are the emissions that are involved with all of the production, the transportation, the material cultivation, and the operational carbon, which is traditionally what people focus on when they think of green building, is your heating and cooling costs, maybe some appliance costs, but it's actually a smaller portion of the building's full carbon footprint than the operation or than the embodied. So our challenge is, how do we reduce the embodied carbon footprint of the materials at the time that they show up at the job site? And the silver bullet to that is using bio-based or plant-derived inputs to create building products from. Right? There's a biogenic uptake of carbon during a plant's life cycle, and you can sequester and permanently lock up that carbon by turning it into a value-added product. So this is Hempitecture, and it's pretty amazing to be here. Thinking back when I applied to this program in fall of 2020, we had a product that we were importing and reselling, no manufacturing base, just two co-founders, not a lot of IP developed around these products, and not necessarily clear path on where to go in new products and new manufacturing facilities and distribution. And now I'm standing here 2 years later with a 30,000 square foot facility that's producing insulation, closing an investor round of over $4.5 million, crowdsourced from retail investors down to $100 to strategic lead investors up to $1.5 million, and more exciting things to come. And that's our facility there in Southern Idaho. So why do we use industrial hemp? Probably the question I get most commonly. Industrial hemp is a very good feedstock for, one, producing a lot of fiber that you can turn into insulation, and two, not taking a lot of water, not taking a lot of fertilizer, and absorbing a lot of carbon on the way to during its growth cycle. So this is what our technology looks like, and we've developed the IP around creating this insulation as well as the patent for the insulation product. So we have both process and product patent. And we also have a way to apply a bio-based fire retardant to our insulation, because that's probably one of the first questions I would get if they had a Q&A portion here is, what happens when the insulation catches fire? Well, it's treated with a non-redless chemical bio-based fire retardant to prevent that from happening. And insulation's in every building, right? And there's a bunch of tailwinds for increasing the amount of insulation going on. And a lot of these tailwinds are coming from the Department of Energy itself. So we have a product line that spans not just cavity insulation, but actually continuous rigid board insulation, which goes on the exterior of your house, acoustic insulation, loose fill insulation, carpet underlayment, and pretty soon interior wallboard. Think a drywall replacement as well. So there's a whole host of products you can make using industrial hemp and other natural fibers, and they all have the added benefit of being very low when it comes to a carbon footprint standpoint. keep speeding through here. So this is actually what our wall assembly looks like. You can see that exterior all the way to the left of the back vented siding system. You put a weather resistant barrier, then you put our continuous insulation sheathing to reduce any thermal bridging or avenues for the energy to escape the home, like the wooden stud frame is typically a thermal bridge a lot of energy can escape through. Our cavity insulation, and then an interior air membrane, producing a very highly energy efficient, low embodied carbon house construction. So our materials are tested and certified. We are in the process with some of these, finished with others. We are bio-based certified product by the USDA. We are seeking ICC ES code compliance, which allows us to go in every residential and commercial building across the country, as well as a health product declaration, which basically ascertains that every single ingredient in our product has no toxicity or potentiality for toxicity. And if you're familiar with insulation, you know it's kind of a dirty material, whether it's spray foam that you need to shut down a house and enter it with a hazmat suit to install, or it's fiberglass with just airborne glass particles that can be inhaled or irritate the skin. Our product, you can see a family installing their insulation there on the right, and that's our product that we sold and provided to them, as well as a dog and a human lying face to face. That's a very different insulation experience than most people are familiar with. And then I'll finish with our momentum slide, and because there's much more to discuss. This has been 5 years working on this project, so I'll be over there in the corner. But 2018, we founded as a public benefit corporation. 2020, we applied to Innovation Crossroads. 2022, we closed a $4.5 million equity crowdfunding round. 7 months later, we started selling insulation from the manufacturing facility we used the funds to create that round for. And now we are also underway with a $1.1 million contract with NYSERDA to produce our loose fill insulation product. And we are underway with a $10 million Series A, 75% of which is already spoken for, including one of the largest insulation manufacturers who's earmarked as our lead, which is a very exciting development we've come to this week, actually. So that's fresh news. I can't name them yet, but it's a very fresh development. And then we have other products and industries we're expanding to: mattress tops, cold freight packaging. The uses of insulation and bio-based products are only becoming more and more commonplace. So I know this is a tight 5 minutes, so come back to my booth and we can talk more. My name's Tommy. We're Hempitecture, and thanks for listening.
Yeah, thanks, Tommy. Yeah, it was really cool. I got to go out to Southern Idaho earlier this year for the grand opening of their facility. That was really rewarding. Also, quick story. When I got to the airport in Boise, I was picking up my rental car. You know, I probably had some compact or mid-sized car, whatever our travel group reserved. And they said, "Oh, all we have left is a Dodge Challenger. You want that?" I said, "Okay. Well, if you've ever been to Idaho and driven on the interstates, you'd know that ended up being a really fun work trip." So, all right. Well, we've got a couple left. And next up, glad to introduce Forrest Schreiber with Sentinel Devices. Forrest.
Thank you, Dan. Hello, everyone. My name is Forrest Schreiber. I'm the co-founder and CEO of Sentinel Devices, and we are a plug-and-play monitoring solution for industrial equipment in manufacturing and defense applications. The problem that we are solving is that AI today, despite the hype, does not help operations or maintenance teams. And there are a few key reasons why that is. One is that there's no tight feedback loop between what these teams learn and what they know in the field and what the model knows and learns. There's no true scalability, especially with cloud-connected solutions, when you're talking about just putting a solution across an entire facility or across multiple facilities. And finally, in 2023, it is always going to be a very touchy subject to bring an internet connection from the outside world into your most critical industrial equipment. The solution, which Innovation Crossroads funded us to develop and bring to the market, is distributed AI that works where the equipment is. So we're actually making the equipment smarter, not the cloud. And this has a few really key benefits that we can give to the customer. One is that it's cheaper on a per unit, per asset basis. Two is that we have low to almost no overhead of installation relative to other solutions. 3, we simplify compliance massively, especially on the cybersecurity front, because they don't need to worry about bringing an internet connection into their facility, which is a very big bonus for some of our defense customers. And finally, by packaging AI in this way, we can actually make every single piece of equipment within a facility self-monitoring and self-reporting and even self-documenting. We've made a lot of tremendous fundamental advances over the past 2 years in the Innovation Crossroads program. I'll start with algorithms. What you see on the top there is real live data that came from an actual train that was running in the wild. This was a passenger train. And you can see on the bottom here is our alarm system. We have a 3-level alarm system. Level 1 indicates to the engineer or operator, hey, it looks like there's something a little bit off, but you can probably keep running. Level 2 is an indication saying, hey, you need to come inspect this. It looks like there's something quite a bit off. And level 3, someone come look at me now because this is a potentially dangerous situation. It's very out of normal. This is an alarm that was actually built into the train. So that green line that you see there was not our alarm. That is the train telling the operator or engineer in the control room of the train, hey, you need to stop this train now because you are in an unsafe situation. This was an air pipe explosion, by the way, that happened. The air pipe, the pressurized air actually ruptured out of the pipe. 30 minutes before that happened, we would already be telling the operator, hey, there's something going on. You need to look at this because this is an emergent situation. And the full value of what we provide to these operators is when they go and say, okay, what do you think is wrong? We don't just say, we're not just digital eyes on saying, hey, there's something going wrong, but good luck figuring out what it is. We can actually pull out the most relevant signals for those operators to see first, so they can very quickly assess what is going on and what they have to do. This is a huge bonus in manufacturing. In fact, we estimate that total downtime we can reduce by as much as 60%. The estimated cost for downtime in manufacturing in 2022 was over $1 trillion. So you can do the math. We have made also fundamental advances in our user interface, going from early stage prototype user interfaces to fully fledged, fully qualified user interfaces that technicians can readily and easily work with in the field. We have gone from initial early stage prototype hardware to fully qualified industrial hardware that can be readily deployed in large quantities out in a facility or across multiple facilities. We've also been funded by the NSF and the US Air Force through their SBIR program. And we've done multiple demonstrations and paid pilots, including one on the left with a small local electrical utility with our early stage demonstration hardware, and one on the right that was actually completed just 2 weeks ago. That picture is very fresh with a system integrator that we were working with. We also have multiple projects that are oncoming in the pipeline. One is with a consumer chemical production company that we are implementing a pilot with right now. One is with a crane monitoring, maintenance, and repair company that we're developing a greenfield trial project with for some of their new cranes. And finally, Northrop Grumman has put us through fully 50% of their InfoSec evaluation process for an eventual deployment on one of their manufacturing lines. In summary, we are a plug-and-play AI monitoring solution for industrial equipment. Think of us like an engineer in a box. We are a TRL-7. We're ready to deploy today. In fact, we've already done multiple deployments, and we're going to be increasing that number over the next few weeks. And I want to give a very warm thank you to the LEEP program for sponsoring and funding Sentinel devices to revolutionize how industrial equipment is monitored today. Thank you.
All right. Thank you, Forrest. And now for our final presenter in the Innovation Crossroads portion of the event, happy to introduce Sam Evans from Unbound Water Technologies.
Use the clicker.
Hi, everyone. My name is Sam Evans with Unbound Water Technologies, and today I'm going to talk to you about a problem that affects us all, and that's industrial pollution. Industrial wastewater is contaminating the world's water, and current remediation methods aren't able to meet the variety of contaminants that are present there. There's high cost and questionable safety of emerging remediation materials, as well as existing methods that are costly and process intensive. In the specific market, we're looking at thermoelectric power plants. They alone contribute over half of this toxic waste that discharges to waters. These cause development issues, cancers, and other central nervous system damages. Coal ash itself is what disproportionately contributes to water contamination here. The estimated cost of cleanup for these coal ash ponds is $75 billion and might be even larger as more things are unearthed and processed. Coal ash is the second largest waste in the country behind household waste. It's expensive and cumbersome, and over 90% of these ponds are leaking into groundwater right now. At Unbound Water Technologies, we believe in the interconnectedness of the world and its resources, especially water, and we exist to sustainably remove toxic pollutants from a variety of concentrated waste sources that end up in our waterways. We've developed an advanced material, CMNA, that can inexpensively clean industrial wastewater in both industrial and remediation. What we do is we take a tire, so we're taking a waste to clean up a waste. We grind that up, pyrolyze it, and use that carbon and do a patented surface coating, integrate it into on-site pump and treat systems or permeable reactive barriers, and remove multiple key pollutants, including 4 that are very important to the coal power industry: selenium, mercury, lead, and arsenic. We're 4 times less expensive than standard carbon black, 200 times less expensive than the emerging carbon competitors, and 5 times more efficient than existing iron nanoparticle remediation methods. Our focus market is going to be the coal ash ponds of large regulated power companies, including TVA, Duke Energy, and others. There are over 700 coal ash ponds in the US and associated territories, and again, a $75 billion price tag for cleanup, most of which is going to fall on the utility rather than ratepayers. We are also investigating other areas, including mining tailings, DOE and DOD, legacy waste, other industrial effluents, as well as household consumer systems. One positive part about our material is that we're able to absorb all these contaminants and then easily strip them. So we can actually collect a variety of different metals, concentrate them, and then use them for applications in the energy sector, catalysis, and others. At Innovation Crossroads, we've been able to advance our technology. We got our patent early in this year. We've done real life testing with coal ash water effluent and removed a variety of different pollutants, including, most importantly, selenium, arsenic, lead, and mercury. We have a pilot coming up in July of this year, as well as later in this fall. So we are looking for investors and strategic partners across those variety of different industries. I think we're most interested in thermoelectric power right now, as well as the mining sector. And with Unbound, we hope to positively impact human health and planet sustainability with a powerful, cost-effective technology. So if you want to talk about water, come find me.
All right. Yeah, I can't tell you how just how cool it's been to work with these outstanding innovators over the past couple of years and to watch them and their startups progress. It's been really awesome, and it's also been good to see the impact that they've had on our ecosystem and our lab as well. So yeah, looking forward to all the great things to come. Now, I'm very honored to introduce Shelley Curtis, who is the director of Westgate at NREL, and who is the newest LEEP node. And it's been actually really impressive watching them stand up this node and to see where they are in this little amount of time. So, Shelley.
Right. Yeah, thanks, Dan. First of all, I want to actually reiterate something that Mary said in your opening remarks. It does take an ecosystem to raise a clean tech community or to raise a clean tech company. it also takes an ecosystem to raise a LEEP node. And so first I want to thank Joe and Paul for trusting us to raise this 4th node. We're really excited about this opportunity. Also want to thank the amazing folks who've gone before us and the shoulders that we're standing on for this node. So Oak Ridge, Berkeley, Argonne. And thanks for everything that you've done for this amazing program. And also want to thank my NREL team, who's mostly sitting up here in the front row, although I saw Johanna in the back as well. It takes an unbelievable amount of effort to stand up a node, and I'm not doing this by myself. This is a team effort of to the nth degree. So thank you. My name is Shelley Curtis. I am the Westgate director. We're excited to join Demo Day today with 3 of our 4 innovators in cohort 1, year 1. We are 7 or 9 months into this cohort, and I'm excited to introduce Andrew Gabor as our first innovator today with Bright Spot Automation.
Thank you, Shelley. So I'm Andrew. I'm a CTO and owner of Bright Spot Automation. We sell testing equipment to image defects in solar cells and solar panels. And I'm going to talk today about how DOE is helping us accelerate our growth with the power of artificial intelligence. So here's a solar panel a company sent me recently. It looks fine, right? Well, here's what it looked like after we imaged it with our electroluminescence or EL testing system in the near infrared. It's full of damage. This is not going to perform fine in the field. Our systems make the invisible visible. So our mission at Bright Spot is to reduce the risk to folks throughout the value chain. It depends who you are. Manufacturers, those risks might be low yields on their lines. It might be warranty claims for system owners. It might be fires or production shortfalls. For insurers, it might be expensive claims. And for aerospace companies, it could be a satellite failure. So we have systems that help our customers see the problems so they can fix them. And our business model is really to sell equipment throughout the entire value chain, everything from R&D to production to testing in the field. No matter where you are, we have a system, whether it's electroluminescence, photoluminescence, or UV fluorescence, that can help people image these defects and solve their problems. So our opportunity for growth is based in part on artificial intelligence. And so right now, a typical system that we're selling sells for something in the neighborhood of $8,000 to $30,000 per system. Once we develop our AI solution, then we can be selling systems for over $100,000. So that accelerate our revenue. We'll also get recurring revenue through maintenance of this software package and even expand into software as a service revenue. Once we have all this data of different technologies, we'll actually be able to monetize the information and statistics in that data. And this is going to stimulate further more hardware sales. And then we have a new really exciting market that's really requires artificial intelligence because it's so high throughput. It's drone UV fluorescence. And here is an example of one of our first flights we took very recently. Here we're imaging systems on a church near our headquarters. You can see almost every solar panel is full of cracked solar cells. This is a real problem. You can see the tremendous throughput our systems can have. So why do we need to automate this with AI? Humans just really aren't good at it. It's very tedious work. It's slow. Humans are expensive and they're incredibly inconsistent. So here you can see some of the first results from our AI model. You can see how we can automate the detection of a wide variety of defects. One of the first places we're going to be implementing this is in a new system we're developing called Mobile Spot. It's something where we can test solar panels prior to installation in the field, and that can reduce risk for the system owners as well as the installers. It can even be done during the daytime. It's a system that will actually go inside of a U-Haul cargo van. So this development's nearly done. And we have great traction so far. We have over 100 customers worldwide, around $700K in revenue last year, mostly in products, and we're profitable excluding our recent investment in AI. I think some of you will recognize some of the names on our customer list. So in terms of competitive advantages, you know, if I can convince somebody to send me a solar cell or solar panel that they want tested, I can nearly always get the sale. Our images are simply the best in the industry. Also, in terms of the new AI software, I've been working at this my entire career. one of the leading experts in the field in terms of defects and degradation and manufacturing. And all this integrated experience is going into our software that will also give it a competitive advantage. And then we've licensed IP on UVF from Southern Company and really are the first mover in this field. We absolutely love Colorado. We are getting great support from NREL, Colorado School of Mines, Energy I-Corps through the Westgate program. And we have a CRADA in place with NREL. We've started work on the AI portion of that with Kristen Perry, and we're about to start work on the UVF part of that. By the end of the CRADA, we hope to have surveyed most of the different technologies scattered throughout the NREL campus and actually shown a new application of UV for use in product development of new module technologies. We just recently won a $250K award from an economic development corporation in Colorado. And we absolutely love working with the Colorado School of Mines. The students there are great. In terms of the team, I've been at this, again, my whole career, which actually started out as a graduate student working at NREL, worked 11 years at Evergreen Solar in manufacturing and elsewhere. And we are looking right now for a new senior person on our team, a software engineer. We're looking to actually hire 2 more folks this year, start work on that new economic development contract, start work on the UVF part of that CRADA, and get our first software, AI software sale, our first mobile spot sale, and crack our first $1 million years in revenue. Continue in the next 2 years to grow both in revenue and in terms of hires, and heads up, we probably looking to raise some funds to accelerate our growth yet further in 2025. So please stop by the table later on. Looking forward to talking to you. Thank you.
This is very exciting to see all of our innovators doing this. Like I said, halfway through our year 1. Next up is Stefan Streckfus from Renewell. Stefan?
All right. Hello, everyone. First off, congratulations on surviving almost 3 hours straight of presentations. I'm impressed with all of you. Today, I'd like to start with a question. Could oil and gas's largest liability become renewable energy's greatest asset? Now, for those of y'all with a great attention span and you're still listening to words coming out of people's mouths, you're probably wondering, what is oil and gas's largest liability? It's their wells. This video shows one small field in California. There's thousands more like it, all with wells that need to be cleaned up. So what's supposed to happen at the end of a well's life? Well, that process you see on the right side of the screen is required in every state or some form of it. But all you really need to know is that it's expensive and there's no return on that investment for the well owner. So basically they're incentivized to avoid it. So what do we get? We get a huge backlog of these wells, about 2.6 million to be exact, and about 1 million more that are on the cusp of inactivity. When you add all that up, it comes out to hundreds of billions of dollars to clean up these wells. And that is a bill that's expensive even for state and federal governments. By current regulatory standards, we've got more than 100 years to clean it up. Unfortunately, we don't have that kind of time because many of them are emitting methane, potent greenhouse gas. So what we want to do is we want to change this paradigm, create a new narrative where instead of being viewed as a pesky liability, these wells are viewed as a resource. I'm Stefan Streckfus, and we are Renewell Energy, creating oil wells that end well. So to really create this new story, what we had to do is we had to go out and find a technology that could benefit from all of this dormant infrastructure. Gravity energy storage is what we think is the perfect complement, because at the end of the day, gravity storage is just potential energy, so mass times gravity times height, and height is a place where wells really excel. Today's gravity storage companies create or access somewhere between 100 and 500 feet of vertical displacement or height. The average well is about 1 mile deep. But before we create that storage, first thing we do, which is very important, is we seal the well, effectively remediating it, stopping that methane and other nasty stuff from coming up onto the surface. And so this is a product we're able to sell. Once we've done that, we then build our energy storage. That involves a weight being installed in the well, lift it to convert electricity over to potential energy, and then lower it to put electricity back on the grid when it's valuable. I mentioned 2 markets, 1 product. First market, the impact is really that we're able to be very low cost because we've got an entry into another market that supports our entry into the energy storage market. So we're the lowest cost option today, but importantly, we're also the only net negative greenhouse gas emissions storage technology on the market. Moving to the right side, coming to the well owner, we reduce the cost for them to remediate the well, which is great, but we also provide a payback on that investment for the first time, finally creating an incentive to clean up those wells. Now at scale, this technology has 3 major positive impacts. First one is carbon emissions, which I've been talking about. This is on the scale of about 18 million cars off the road. Second one is streamlining the oil and gas workforce transition because we use the same people, processes, and equipment. And the third is that we cut out about $19 billion of cost from the deployment of energy storage to create a renewable energy future. We've been super lucky with the team we brought on board so far. Some really incredible minds, people that have balanced the electrical grid in Hawaii, built spacecraft, quite a bit of oil and gas experience. Also, I'd like to call out on the advisory board, we have the most recent CEO of our 2nd largest beachhead customer, which is pretty exciting for us. We've also, over the last year, gathered quite a bit of momentum in the form of, got about $6.5 million of capital to work with, a couple of successful pilots, and looking forward, the Infrastructure Bill and Inflation Reduction Act are incredibly well suited to the technology we're building. Now, 2023 is very much a technical development year for us. We've got quite a few technical resources in the form of the funding we've got through Westgate, which is really meaningful to us, and also working with School of Mines. On top of that, a grant from ARPA-E, all of which will deliver some really major proof points, most of which is centered around us establishing the economics of this concept as it scales. And then with that, going to continue to build with targeting deployment of 25 of these systems in 2025, and a lot of preparation that goes into that. But really all of this is driving towards what we are trying to do is establish momentum to create this new marketplace I described. And in this marketplace, we want to take the $2 billion that today is spent tearing out old oil and gas infrastructure and divert it into the lowest cost, greenest energy storage available. Essentially converting oil and gas's largest liability into renewable energy's greatest asset. Thank you, guys.
Okay, and our third innovator today is Grant Gunnison with Zero Homes. Grant, take it away.
Thanks, Shelley. My name is Grant Gunnison. I'm founder of Zero Homes. We are helping folks electrify their homes in an easy way. Really, the problem we're attacking is single-family homes have a massive climate problem. They're emitting 20% of all of the emissions today in the US, and that's a very distributed problem. Roughly 60 million homes directly contribute to that, so it's a little bit from every one of those every day. And it's an expensive problem. $50,000 roughly needs to be spent on every home in order to electrify them. That's a huge pain in the butt for a homeowner and a huge opportunity for our business. But the real challenging issue here is home electrification has a human problem. This is really hard to do. It's excruciating for homeowners to have contractors come over to help educate them on what to do. It's extremely time consuming. That research and planning phase can take homeowners 50 to 100 hours to complete. I don't know how many homeowners there are in the room, but I'm sure you don't have 50 or 100 hours to spend electrifying your HVAC, installing solar, and the like. The flip side of that is it's very expensive for contractors. They're going out on their own dime to provide quotes and educate consumers, and their conversion rates are very low, which means their funnel costs are ballooning dramatically. All told, mailing a human to a house to educate someone about how to replace their HVAC just is not a recipe for success. We need to put this in the digital world, enable people to go faster with that. Or as said in the industry, truck rolls aren't really what we need to be doing. So we're building a solution transforming this research and planning phase into the digital world, enabling homeowners to communicate what their home looks like in high fidelity to us. We have built a system to process that information, to design scope of work, to price these projects and deliver that to consumers very quickly. While you're sitting on your couch in your footy pajamas, you can actually select a contractor, schedule with them, and then you can get them to install that project without having anyone to come over to your house first. It's really a 10x better consumer experience and will enable everyone to move a lot faster than they are today. This all starts with a digital assessment. We guide homeowners throughout their house to help them communicate to us what their home looks like. We're enabling them to snap pictures, nothing new there really, but we're enabling them to scan their house, create a 3D model of their house, which we break down and help design HVAC systems for. We enable them to communicate what their installation levels are or aren't at all in their house, authorize their utility bills, so on and so forth. And we take that to build a digital model of their home, and so we can actually design projects for them. We turn that into real value, so folks get real scopes of work, not just, hey, you should do a heat pump, but actually the equipment specifications, how much money they might save, the financing that comes with that, and a real price that we're willing to take to deliver that project. We're focused on heat pumps for space heating and cooling and water heating, but we're also doing solar, electrical, cooking, EV chargers, the like. It's a one-stop shop to get really any home energy upgrade done in your home today. The value proposition for homeowners is enormous. They're saving 90% of the time they would have spent in the research and planning phase. They're getting quotes turned around in 24 hours as opposed to begging contractors to give them to them in weeks. And we're actually meaningfully reducing project costs by just operating much more efficiently than sending folks over to homes. For contractors, they're saving huge amounts of time, which is really important because we need many more people to actually deploy these technologies in homes, as opposed to doing sales and marketing, ordering equipment, signing permits, and the like. We want to help folks do functional work, which makes them happy because that's what they're good at. And more importantly, that's what makes them money. Leveraging our software, we're building a technology-enabled marketplace. We can talk about the unit economics of what that looks like. Please see me after. But really, we're building a solution that lifts all boats and enables contractors to get more work done faster and enables a 10x better experience for homeowners. And the market opportunity for this, it's bananas. $150 billion was spent on home improvement in the US last year. $50 billion of that was focused on home energy projects. And these are the dollars that Zero could capture from that spending. In terms of where we're at, this project started about 2 years ago. We developed an initial proof of concept, deployed that with about 100 customers. We sold through a few $100,000 in projects and leveraged that into both getting into Westgate as well as raising a recent financing round. Those dollars are going to be used to continue to automate our workflows, which will enable us to deliver scopes of work and pricing to homeowners in minutes as opposed to 24 hours. And by the end of the program, really our goal is to be set up for success and very large scale deployment. Somewhere in the 24-25 timeframe, we anticipate being able to serve tens of thousands of customers a year. Today, our team is very small. We have a lot to do. Most importantly, build a bigger team. We have several roles open. If what I've described to you today resonates with you or someone in your network, please get them in touch with us. And if these roles aren't a fit for those folks, we're going to have several more coming out. So stay tuned. We'd love to talk with them. And thanks for your time. Please come by the booth. Happy to give you a demo of how this works and look forward to chatting. Thanks.
All right, and that is it for Westgate. I do want to say two more things. One, our fourth innovator is not here because he's actually in Sweden. He's on the short list of finalists for the H&M Global Change Award. We'll find out literally at 8 a.m. tomorrow morning. I was hoping it was going to be today. He's one of about, I think there's 10 left out of about 1,000. So we're really excited about hopefully some good news tomorrow. So keep your fingers crossed for Terraform and Mike Konev, who is our fourth innovator. That's it for Westgate. Thanks again to Dick and your team. I especially want to call out Janelle, who put in an unbelievable amount of work to push this thing off. And She was on the phone or email with us almost every day for the last couple of weeks. So thank you to the team. Thanks.
Great, thank you, Shelley. And as Steve Jobs would have famously say, there's one more thing. So just to show you how collaborative LEEP is, I want to invite up Cliff Chen, our next speaker coming from New Mexico. As Dr. Richmond mentioned, we have SC and ERE labs, but we also have labs outside of that. And with that is the New Mexico LEEP program. And I want to invite up Cliff Chen to give the final presentation today. Thank you.
So hi, everyone. My name is Cliff Chen, CEO of OM Photonics. The technology we are developing is a next generation camera-like 4D imaging LiDAR system, which offers high precision, high resolution, and long-range sensing capability. Based on silicon photonics technology, our sensor is compact, lightweight, power efficient, and shock resistant. LiDAR has many applications spanning from space exploration, military, to many civilian applications like robotics, augmented realities, and biomedical imaging. These applications require detection range from a few centimeters to hundreds of kilometers. For us, we specifically focus on automotive and drone applications in which the detection range is in the order of a few hundred meters. For the beachhead, we start with drone because drone has a lower entry barrier as compared to automotive. Also, drone users has immediate needs that are described in the next few slides. Using LiDAR with a drone is very powerful in providing detailed aerial 3D mapping of a terrain. Applications of LiDAR with a drone include topography, precision agriculture, environment management, and many other use cases that require a LiDAR with high performance, lightweight, compactness, and reliability. The use of LiDAR drone in these applications can create significant economic benefits. For example, we have heard from construction site surveyors that using LiDAR drone can save them more than 2/3 of the project cost as compared to using conventional surveying methods. LiDAR drones is a game changer for surveying, monitoring, inspection, and mapping. And not only can create significant economical benefits, but also can help reduce the risk to human life in performing these tasks. However, to achieve the performance required for drone applications, especially when involving dense vegetations, one usually needs a very high-end or high-performance so-called survey-grade LiDARs. We have talked to stakeholders in the LiDAR drone industry, including like drone manufacturers and the end users, and all of them express that current survey-grade LiDARs are expensive, heavy, and bulky. And the weight of the size issues of the current survey-grade LiDARs not only limit the flight time of the drones, but also inhibit their uses in smaller, cheaper, and more popular drone models. Additionally, the end users that we talk to repeatedly express that drone crashes occasionally, and these current survey-grade LiDAR, they are prone to mechanical damage upon crashes. The crash not only cost the LiDAR owners thousands of dollars, but also months of time to repair the damaged system. Our camera-like LiDAR system is able to solve all these problems by providing a reliable, compact, and lightweight solution without any compromise in performance. Our solution specifically addresses the demands of the fast-growing drone applications. Our sensor has a huge potential in view of the $1 billion worth LiDAR market. For the reference serviceable available market of the LiDAR sensor in the beachheads, it is expected to have an annual growth rate of more than 29% in the next few years. Here is a comparison of our sensor to our competitors. In the field of 3D topographic mapping, Rigo is the dominant player. Rigo set the gold standard of a high-end survey-grade LiDARs. However, Rigo LiDARs fall short in physical specifications and cost. Companies like Geraldine or Levos, they offer lightweight and lower cost alternative, but with their performances sacrificed. For us, we are able to achieve high performance by leveraging the advanced detection FMCW detection method, which is 10 times more sensitive than the time of flight methods used by our competitors. Also, based on the solid-state silicon photonic technology, we are able to achieve small size, lightweight, and low power consumption based on our proprietary designs. Other than the drone LiDARs, we also compare with the companies whose focus is in automotive. The bottom line is that, as far as I know, our technology is the only one that can excel in both performance and physical specifications. We have studied the ecosystem of the LiDAR drone industry, and we realized that our immediate customers are the drone manufacturers and system integrators. So we have reached out to them, and they all express very strong interest in our technology. And specifically, one of the well-known system integrator, LiDAR USA, has agreed to work with us and to beta test our prototype when it is available. So for the go-to-market plan, downstream the value chain, we will partner with the system integrator. They are our customer, but they are also our distributor for the US and international markets. We'll be market presence through trade shows and conferences. So upstream the value chain, we'll partner and outsource with the manufacturers to build our sensors. For the next few years, our main focus will be the hardware development of the LiDAR sensor for the UAV market. At a later time, we also focus on the LiDAR data, because it is the data that the end users they are most concerned about. When we have developed our technology and set a firm foundation of the company, by 2026-27, we project that we'll begin to tap into other markets like the automotive markets. The core technology of a LiDAR is the photonic chip, also called the PIC chip, which includes both the optical transmitter and the receiver. Just like a camera sensor, we are able to achieve very high spatial resolution by having many pixels for the transmitter and the receiver. And at the same time, the receiver pixels is able to perform coherent detection, which makes long distance and high ranging resolution possible. We have gone through 2 cycles of the design, fabrication, and testing. And the next step is to integrate electronics, laser, and optics to make a complete LiDAR sensing module. With the New Mexico LEEP program, which provides us with financial assistance as well as technical support, which accelerate the development of our electronic and photonic chip. So far, we have raised about 1.7 million non-dilutive funds, which include an SBIR phase 2 grant just awarded last month. So we project that in order to have a first product to market, we need an additional about $3 million for the next few years. Here is a very complicated graph, but the bottom line is that we project that in around 2025, when we have our first product to the market, we will begin to generate revenue. And we also expect to break even in 2026 when we have our sale and production ramp up. In 2027 to generate profits. For the exit strategy, we anticipate that like by 2026-27, when we have our technology developed and set a firm foundation of company, other drone LiDAR company may be interested in acquiring us before we will grow or expand significantly. Additionally, we also expect that automotive LiDAR companies will be very interested in our technology and products. And finally, this is a Starbucks team. Also, we have a very small team, but we have a plan to grow our company very soon. And last but not least, I would like to thank the New Mexico LEEP program, which provides us a lot of resources, especially our mentors. And if I have any question, I'll be happy to chat with you, and please visit us at our booth. Thank you very much.
All right, thank you, everyone. And we really can't do this alone, right? And we really need and rely on the sponsorship of our partners. So here I want to, again, thank Wells Fargo and Activate for their sponsorship, and Constellation and Cooley. So to close, I would like to invite Colleen Wright, Vice President of Corporate Strategy at Constellation, to give the closing remarks. Thank you, Colleen.
I'm definitely everybody's least favorite speaker today because I'm standing between you and being able to talk to all the amazing innovators today. A little background. If you're not familiar with Constellation, we're the largest clean energy supplier in the US. We supply about 170 terawatt hours of nuclear power to the grid every year. And we are also serve 200 million customers, or sorry, 2 million customers. 200 million customers would be a lot. And that's 75 of the Fortune 100. So one of our missions is a new company. We recently separated from Exelon as of about 1.5 years ago. The mission of our new company is to accelerate the fight against climate change, which can feel incredibly overwhelming, especially on a day like today where there are advisories to stay indoors because of all of the fires in Canada. So definitely a huge challenge to face here. Sometimes 2050 sounds really far away, but the one that's in here right now is going to be 27 in 2050. So it's really not that far away. Everybody says your kids grow up really fast. So if you have older children and you think about that 27-year period, it's really not that far away. We've got a lot of work to do. The policy and technology challenges ahead of us are incredible, and it's really inspiring to be here today with everybody and be able to participate and support the Argonne and LEEP programs to achieve these great challenges and work with the innovators in this room. Really excited to speak with folks. So thank you for all of the work that you guys are doing to innovate and help us achieve our climate goals. And also congratulations to all of the innovators. So thanks for having us. We're happy to be here.
Well, we did it. We heard from 20 amazing innovators. And if you didn't believe in the 3 core beliefs when we started in the day, I hope you are now believers that the LEEP platform is a way to open the national labs doors to the entrepreneurs of tomorrow. We've seen different flavors, we've seen different approaches, different types of innovators, but at the core is every lab is opening its doors to these innovators. So again, thank you for being here today with us. And I really want to thank Dr. Richmond for spending precious time with us, and Lab DOE, our colleagues from DOE, to be here with us, and lab leadership. And again, this is really raised by an ecosystem. And what we're learning today is this ecosystem grows from regional to national. So let's celebrate that ecosystem. Stick around. Our innovators are excited to speak with you. We also have food and beverages over there. So please help yourself and enjoy some science and technology. So thank you, everyone.